first sound has like the typical speed or has 238 meters per second, first sound speed. And then second sound is 20 meters per second. And I guess that could be miles. It's temperature dependent. Because like one thing that's crazy about superfluid is it's like uh, convection is like insane. It's like incredibly efficient at heat transfer, like insanely efficient, to where they've had to like basically come up with some new quantum phenomena, like new quantum state of like super efficient heat transfer and convection. So apparently, sound inside the superfluid it interacts. Its speed is relative to the temperature. Mm. Dude, superfluid is wild, bro. I'm just saying, if superfluid is what's filling all of quote unquote space, then that would explain why we're nowhere close to understanding what's going on there.
Did you say that we've created superfluid, like the experiment? I did kind of briefly try to look this up, but
Yeah,
if you know
yeah.
anything.
We've created superfluid with helium and recently hydrogen.
And they
what's
even
the
used it
process?
to detect the rotation of the Earth as it becomes an extreme accurate gyroscope.
Okay. I'd be kind of curious, how do they go about the process of like what do they pump the helium into a canister under a certain pressure and then introduce any sort of like electrical induction or something?
So
No,
I
it's
don't
just
know.
lowering the temperature and
Yeah,
pressure. Yeah.
it's extremely low, like cryogenic temperatures. And so, like when you,
When it comes to luminance, the spectrum is from ultraviolet to visible and potential, as I said, potentially and infrared. That's
So
the electromagnetic spectrum coming off
okay.
what's the
sonoluminescence.
word
But so
called? What's the word called when you make it super cold with like liquid? It's like we did it in like science class, and you had to put your gloves on. It's like um, liqua. Um, Liquefaction is a process that can turn a solid or gas into a liquid, or create a non-liquid phase that behaves like a fluid. It is also something to do with earthquakes. So you're right. Liquefaction is the process where saturated soil temporarily loses its strength and behaves like a liquid. There you go. So
so
anyway, so
that's
that's
like
where
the
it
process.
does have to do with
Yeah.
superfluid, though.
Have you ever seen where they pump air up through sand and then all of this like quicksand basically? It's just that
No.
kind of it's a similar yeah, so if you take a chamber with a sort of a ground bed of sand and then you start pumping up the air through the sand, anything of any of like a more density than the sand will just it starts behaving like a liquid effectively.
Dude, guys, don't you think it's insane that they messed with plasma and magnetic fields in the lab and replicated the galaxies? Like I didn't even know that. I was just thinking about like, okay, we see a lot of phenomena that's consistent with plasma. If you had like a really tenuous gas, then if it was ionized, then it would be a plasma, right? And what started me on that thought process is, for one, I realized that they did invoke plasma. We know that plasma would give you like the medium needed for magnetic and electric fields and stuff like that. And clearly, whatever's happening in quote unquote space is electric and magnetic. But also, Tesla described the ether as the primary substance that has a tenuity beyond conception, meaning it's like rarefied. It's just insanely mind blowingly, like inconceivably thin, right? And then I know that like with this like interstellar medium idea that they claim that there's like basically plasma, like ionized gas and different gases, but it's super thin, like thousands of times thinner than what the gases on Earth. So it just started me down this avenue where I'm like, okay, plasma, and then if you look at galaxies, they just look like magnetic fields in a ferrocell. Like they look just like a magnetic field. And magnetic fields have a vortex, right? So then you see like spiral galaxies, you see the galaxy rotational speed problem and all this stuff. And so you're like, okay, doesn't that just look like a giant magnetic field? Are we all going to sit here and pretend that that's not what that looks like? Like, really, bro? And if you had a giant magnetic field with a vortex, you would have things rotate around the center. And of course, they would claim that there's like gravity and everything's rotating around it. And then I realized they claim gravity wells, which is basically would just be the vortex, right? It would be a vortex. That's what the gravity well would be basically. If things are rotating around that quote unquote gravity well, they conceptualize it like dropping a bowling ball in that fabric and it's going to roll around until it gets to the center. But if it's a vortex, it's just going to roll around the center. You're going to have that same geometry of a gravity well. You know what I mean? So it's like starts becoming very obvious that their interpretation of like relativity in space is basically just hijacking the ether, where they claim gravity is an emergent property, a secondary emergent property. Well, that's true. The effects attributed to gravity would just be an emergent property of the fluid background. And that it bending and waving and curving, well, yeah, that's true. That would just be the waves of a background medium. Space-time curvature would just be the waving. So yeah, it does technically bend, right? So it would be the waving of the medium. And then you would get the gravity wells, which would be like these vortices, and then you would get the rotational motion around the center of the vortices, which would be just the magnetic field itself. And then if you look at how they depict black holes, it looks identical to ferrocell images. Like the center of the magnetic field is like a little black hole. So clearly, we don't actually see black holes, of course, but they claim that there are certain areas where it looks like something like a black hole. It would just be our super strong magnetic field, which is basically an ether portal. So when you start to stack it all up, it's just so obvious that it's electric universe. It's much more dense, much more local, it's much younger, it's much closer, etc. And everything's fluid like. And you have the primary substance, the background medium, which is a fluid state that's super tenuous and rarefied. And then it's excited, it turns into different modalities. And then you would get stuff like superfluid as one of the initial states. So like the ether would basically be the primary state. It would be inertial, it would be stillness, be perfect rest. And then once it's knocked out of that state, you would start to get super tenuous mediums like liquid, super fluid, and helium and hydrogen and different states of that. And then you're going to get these gases. If they're ionized, you get plasma. So anyway, so you have like plasma and magnetic fields, right? And then what do you know? You look up plasma magnetic fields and galaxies, and you find out that going all the way back to the 50s, they were replicating galaxies with magnetic fields and plasma in a lab. And that even to now, like they're able to replicate like super precise like phenomena observed in the sky using different variations of magnetic fields and plasmas. Like, bro, really? Like, okay. It's kind
So
of like game
so
over.
each galaxy must have its own magnetic field surrounding it. Then
I think so. Yeah, I think it is the magnetic field. So, like, if you understand how a ferrocell works, this is going to explain how we're seeing the galaxy. It's the same way you can see the
yeah, that's what I
magnetic
mean.
field,
So
but
in your
we're
model,
not actually
then every single
galaxy
galaxy
is a
must have
magnetic
its
field.
own. Will need to be within a ferrocell or a ferrocell
Well,
like
yeah. Yeah, it
magnetic
would
field.
be in the analogy, yeah. Like when we see the galaxy, it would be like seeing the magnetic field in a ferrocell. But we're not actually seeing the magnetic field in the ferrocell. We're seeing the fluid, right, being lit up. And so like you take ferrofluid and then some other type of fluid. It's like rat oil or something like that's what it's called. It's like the best brand to use. You put a couple drops of ferrofluid in that other oil, that other fluid, to compress it between two really flat pieces of glass. You super glue the outside or whatever. You wrap an LED light around it, and when you put it over a magnetic field and look through the glass, you'll see the shape of the magnetic field. It's like beautiful. And it's of course because the magnetic field is reacting to the ferrofluid and it's pushing and distributing that fluid around, and then the light is just reacting to its scattering based on that fluid's distribution. It's giving you what the magnetic field looks like. So that ferrocell would basically be like a crude imitation of the natural ferrocell that is a galaxy in space. So you have the magnetic field, you're able to see it because it's in a fluid and there's light. The light is, of course, lighting up the fluid, and the magnetic field is distributing that fluid, and therefore you're getting to see it. And when you start to, if you take ferrocell cell images and set them beside galaxies, or take ferrocell cell images and set them beside quote unquote black holes, they're identical, bro. Identical. Just a coincidence? I'm supposed to believe it's just a
Could you
coincidence?
repeat
It's
that?
actually,
Yeah, sorry, I missed it. What did
if
you
you
say
take if
about
you
black
take
holes?
ferrocell,
There are
if you well, black holes, we often don't actually have pictures of black holes. Like the whole entire idea in and of itself is goofy because they claim that light can't escape a black hole. So how could you take a picture of it? Dun dun
But
dun,
they've
right?
taken
But
pictures of black holes before.
that's not how they took the
no, they don't
Yeah,
actually take
yeah,
image of
pictures
the
of black
accretion
holes.
disk.
yeah,
They
they took a
took the
picture.
image of the accretion disk and not the black hole itself.
Well, actually, they ran it through a lot of like computer softwares and created an animated image based on what basically things moving around, like the center portion that can't be seen. But anyway, with the quote unquote image that we have, if you take that and you set it side by side to a ferrocell image, it looks exactly the same. In fact, I could mix a bunch of different ones up and you wouldn't be able to tell which is which. You would not be able to tell me which one was supposedly an image of the black hole and which one was a ferrocell image. They look that identical. And if you look at ferrocell images of magnetic fields, because there's all kinds of different magnets, right? So when you put the ferrocell over different magnets, you get different geometric expressions. And you could put pictures of galaxies, images of galaxies, side by side with ferrocell images, and they look identical as well. Am I supposed to believe that's just a coincidence? Because then when we go in a lab and we take plasma and we introduce magnetic fields, we get what looks like galaxies. If you put them side by side, they look identical again.
So they keep like tiny, or how should I say, the stars or whatever,
We're not putting little
at
stars in
specific
there,
points, and
obviously.
huh?
We're obviously not putting little stars in the plasma, but what it does is you can replicate like the spiral galaxies and like the arms of the galaxies. And
But that's just pure gas, though, and not objects.
why would objects not be able to move? Okay, dude, this
No,
is
no.
the worst argument.
In
I'm
those
just gonna make the point.
examples,
If
in the
you've
plasma
evolved to
examples in
this
the
point,
lab, the plasma
you've
example.
conceded.
Could I finish? The plasma sample is just gas, ionized gas. There are no. How should I put it? Stars or exoplanets or
I get
anything.
your point. Yeah. Bro, if we've gotten to this point, you've basically conceded because in your own paradigm, gravity, right? It's like magnetism, meaning if you had a strong enough gravitational field, it would be imperceptible the difference between that and a magnetic field. You have the center of mass, the center of the gravitational field, right? And then you have the center of the magnetic field. You would have things rotate around the center, be pulled in towards the center, et cetera, et cetera. It's the same thing. It's a field of force relative to the center. That's why whenever you guys try to replicate things like how you could have an atmosphere next to a vacuum without a container, right? And you try to replicate that, what do you use? What do you
Isn't
guys
that
invoke
exactly the
as the
reason?
example? What do you guys invoke as the example of a physical demonstration showing the possibility of having gas pressure without a physical container?
Isn't that exactly why it shouldn't be considered like just a coincidence, though? I mean, it shouldn't be surprising if Coulomb's law and gravitational law are so similar, right? Like we can replicate what looks like gravity on large scales with electromagnetism on small scales.
Okay, but you not get the point. For one, the gravity doesn't work at all because when we actually take gravity and apply it to the observation, it doesn't work because it's missing a ton of mass. The gravitational
Yeah,
force
it's a
have to
little
be
bit.
way too strong for the amount of matter that's there. That's not a problem for magnetism, right? Because magnetism isn't proportionate to mass. It's based on field strength. So it doesn't matter how much visible mass is there. You could obviously have a strong enough magnetic field. It doesn't matter how much matter's there. Furthermore, the coincidence isn't as simple as like the motion is similar. No, it's like you're literally replicating galaxies' shapes, right? Like with like the spiral galaxies with the arms that they have, the extensions, all these things. And that's because that's like they're natural geometric manifestations when magnetic fields interact with plasma specifically, which is exclusive. That gravity is not the same as that. So I'm just pointing out that you can't claim like the idea of like, oh, but that's not having stars and stuff move around it. That doesn't help. I mean, right? Like gravity, magnetism, whatever, it's a field of force relative to the center going to cause things to move around it. That's the
Yeah,
easiest
to a
part.
degree.
If there are
I
stars
think, I
inside of
mean,
a plasma, they would move around with the medium that moved around with the magnetic field. Duh.
and I think that should have some similarity to gravity as well. But on the challenge you posed earlier, like I'd happily take up the challenge to differentiate ferrocells versus gravity versus galaxies. I think there will be some differences that you could probably pick up on.
Okay, well, you think there would be probably. I mean, that's cool, but there are tons of different types of magnetic fields and tons of different types of galaxies. But again, if you actually look into it, I'll drop some papers here. Going all the way back to the 50s, they were able to replicate tons of different types of galaxies with magnetic fields inside of plasma. But what you didn't address is the obvious superiority of the magnetic explanation to gravity because gravity is limited to proportionate mass, and the observations directly refute the gravitational claim because there isn't enough matter or mass.
Well, so I've been thinking about this actually, and so starting with the premise that gravity is uh, responsible for what we see at large scales, we've come to a conclusion that we are missing, what is it, 26% of matter, right? 70% of energy, the whole dark energy, dark matter
Yeah,
total is
yeah,
like,
83% of all matter has to be dark matter.
no, I think I got to look it up. I think
You're
dark
right about
matter
the
is less than dark
let me
energy.
help you. You're right about the percentage of the total composition of the universe,
Mhm.
right? So like the total composition of the universe, like 100%, 96% of it is dark matter and dark energy combined. There's something like 20 something
Right.
percent matter and then 70% energy. But what I'm saying is like 83% of the total matter in the universe is dark matter
Mhm.
in your paradigm. So 83%
Like
of the
matter
matter.
energy, you're saying with like the matter energy equivalence or just matter matter?
No. Just what I'm saying is, bro, like there's a certain amount of matter in the universe, right?
Hmm.
And 83% of that total would have to be dark matter, meaning 83% of the total matter is dark, not
I'm pretty
83% of
sure
the total universe. I don't know why it's always like other people. Not just the total amount of matter in the universe, 83% of that total amount of matter is dark, but the matter only makes up like 30% of the universe. So the
Isn't that
universe
the
and
opposite?
only
It's about
30% or so
27%.
of the
Yeah, it's
universe
about
is made up of
20
matter, but of that 30%, 83% would have to be dark. Does that make sense?
from
So
my
roughly 30.
understanding, they reckon that 27% of the mass in the universe is dark matter.
Yeah,
No.
that's what I'm
That's
getting to.
incorrect. Well, you guys can
And then
fact
you
check me,
have
but I
the
know I'm right. So
dark energy, which is something else.
you can fact check me, but I know I'm right. So I'll try to say it this way. So if say 83% of the matter in the universe is dark, then that leaves us like roughly 17%. So let's just say that if they say the universe is 27% dark matter, then roughly 30% of the universe is matter, just in general. Just general matter. You have energy and matter. 30% of the universe is matter,
I see what
70%
you're
is
saying.
energy. Just rough numbers. Okay. So of that 30% of the universe that's matter, 83% of that has to be dark matter.
Right. So my question
Yeah,
earlier was, are
non-baryonic
you
matter.
considering
Yeah.
like,
It's
yeah, I was
85.
asking, are you considering like matter energy conversion? The answer to that question would have been yes then. But I get
No,
what
the
you're.
answer is not yes. The answer is
85%
not
matter is
yes.
dark.
Yeah, 85. Some say 83. Some say 87. Because they don't know how
Sure.
much
The
total
point.
matter is in the universe, so it's going to always be changing.
Sure. My point was, right, you start from gravity and you get to, we have this discrepancy that we fill in with dark matter, right?
Mhm.
I suspect, because we haven't done it yet, if we start with electromagnetism and base uh, the the extents of the universe on that, I would suspect that we would come up with possibly even a greater discrepancy. Like if we
Why?
base the movement of the stars based on charge, because I don't think you can explain it with charge, right? There's an equivalence to matter that we can test has proportion to its attraction. We can test the proportion to attraction to an object's charge. And for example, people talk about that effect where you charge a rod and you can make like a piece of tinfoil float, right? In order to do that
Mhm.
with a bus, the charge would have to be immensely more. You'd have to have immensely
Mhm.
more charge, right? And I don't think you're going to
Mhm.
find that.
But we're not invoking that. We're invoking magnetism.
Sure,
So
either
like
way,
let's no, it's not either way. They're totally different. So let's think about
I
yeah,
know they're
you're right.
different,
If we were
but my
invoking
point's still
static
the same.
electric if we were invoking static electricity to explain the motion, then yes, we would need a mind-blowingly large amount of static electricity. Right. And then you could claim, well, this is the amount of visible matter, and there's a mass charge equivalence, right? And the mass charge ratio doesn't yield enough charge to give you the amount you need to cause this motion. For one, that would be yielding your claim of the amount of mass, which I would reject, but it doesn't matter because I'm not invoking that. I'm invoking magnetism. So like if we think about like two magnets, like two pieces of metal before they're magnets, like neodymium iron boron, right? It's like the strongest magnet we have. And they're both like the
Mhm.
size of a quarter, right? What we're gonna do is
Mhm.
introduce like electrical charge, or we can like introduce like intense heat, and this is how we magnetize that piece of metal. So we introduce voltage to it, and it becomes a magnet, right? And basically, in like really crude terms, it takes like the vibrational components of the constituent like components, whether you think they're molecules or whatever, it overpowers them with a much stronger voltage that's introduced and then aligns them all in the same direction. So the gyroelectric alignment then gives you like coherency that gives you a magnet. It doesn't matter, whatever. Point is that we create the magnet. Well, I can have two identical size magnets. They're both size of a quarter, and one could be 1,000 times stronger than the other. They can have the exact same mass, but one of them can be 1,000 times stronger than the other. It's just based on
Right.
the
So
coherency and the field strength. So my point is now if we look at space, right, like all we would have to do is move that slider around of the magnetic field strength. And then they would get into you could try to make some claim right now and as to like, well, we know we would need this, this, and this for magnetism, but your paradigm doesn't understand magnetism and it invokes virtual photons to explain why there's way more energy than the particle physics model would predict, which is a great benefit to my model here because yeah, again, we just need to explain the high energy needed. So it's super easy to do that because magnetism does that. You know about that, of course, right? That to explain
yeah,
electricity, static electricity, and magnetism in your paradigm, you have to invoke virtual photons because the energy is too great. Like there's way too much
on a
energy observed in magnetism.
yeah on a fundamental level, but I mean, sure. Like, so what makes one magnet stronger than another?
Well, I mean, this is a whole conversation. Great question. I could just say great question because magnetism isn't fully understood in physics, But because again, you have to invoke virtual photons in the mainstream model, which aren't real. But I would say it's the coherency, meaning like how aligned the actual field is. And then when we get into, well, if it's matter, you have like whatever the constituent parts of the matter is. So you could claim they're atoms and then molecules, whatever. We can rock with that for intents and purposes. It doesn't matter. They're all kind of vibrating in their own way. So they're like discombobulated, they're incoherent whenever something's not magnetized. When you introduce like a super strong electrical charge, it overpowers them, and so the direction that you introduce it and it exits, it aligns all of those molecules in the same direction. Once they're all aligned in the same direction, now they become coherent. They're working together basically instead of being all discombobulated and working against each other. And that gives you a magnetic field. And so the strength of that alignment or coherency is what gives you a magnetic field strength. But again, just
Okay,
to
so
reiterate, like I could just say, good question. We don't understand magnetism in mainstream physics.
that so that's fair. I would caution in that case not to put all your eggs in that basket. Then, I mean, if we have such little understanding of that, and you're sounds like you're kind of hinging everything on that. I would be a little skeptical. I mean, I am skeptical, I guess, but um,
But
I've
why though?
asked you
Like
before,
it
and I don't.
answers everything. I
Yeah,
mean, I can
but
tell.
I
I
mean,
think I can explain magnetism.
ex-
I just don't think that you can.
sure,
Like I don't think the mainstream
explanatory
can.
Well,
models
how
are
do you explain it? Manufacturer?
It's
no, no,
just an
no. That's
ether
not the point.
modality. It's just
Explanatory,
an ether modality.
Oh wait, let's let him answer.
right?
He's gonna ask other people.
But
I want
that's
to hear his
invoking a bunch of
explanation.
things. Yeah, I have no idea. But the point is that having an explanatory model isn't as good as having a predictive one, right? Like I can explain everything perfectly coherently with just inventing some random, not ether, but anything else, and I can explain every single aspect of the universe. That doesn't. All my work is still ahead of me in proving that that thing actually exists, that it works like I say I do, right? Like all of that is then dependent
I
on
don't have
actual
to do
experiment.
any of that though, because magnetism does exist. It's proven to exist, and we know like what it does. In fact, we can once we added virtual photons to the equation, it gave us the most precise prediction in the history of physics. We just had
Sure,
to
and
make
all the physicists
corrections
know how
to it.
magnets. Yeah, and physicists know that magnets exist and magnetism exists, and they've still fallen on the side of it's not magnetism, it's gravity, even with all
No,
the
well,
problems
yeah, but
gravity
why?
has.
Why did they do that? Why do they do that?
That's an excellent question.
Because the implications of it being magnetism are so insane. Like no one in the mainstream academic circle is going to come out and say stake their career and reputation on here's my new model that's a geocentric universe with a fluid background medium that has and the universe is much more dense and everything's much more small and local and finite and everything's electric and magnetic even yeah, I mean, even though it can
Yeah,
explain everything way better, they're not gonna do that because the Copernican principle alone would be career suicide.
not just career suicide, but it goes against what we actually do know. Like we do know the distances to some things. We might not have it exactly right, but we know it's not nearly as local as it ought to be for those things to be the cause.
What? No, we don't know that. Like, well, how do we know that? Like, I mean, for sure the stuff in the sky is pretty far away, right? But 20,000 miles, 100,000 miles would be really far away. A million
For a
miles would
human,
be really
sure,
far away.
but
Well,
not for a
just
planet.
well, planets aren't things, and they're not sentient, and they don't have like a measure of what's far. Like the point is like, why would it matter? You agree that if something was closer, it could just be smaller.
Yeah, but
Okay, so
I
things,
say we know that they're not.
yeah, but you don't know that, right? And I have to always
I
just
do.
invoke Edwin Hubble here. Like when Edwin Hubble made his observations, and then people started proposing their idea for redshift. He said that he doesn't just jump on this like recessional velocity interpretation. And if they were something more akin to velocity shifts, then it would perfectly explain the phenomena. And it would just mean that the universe is much more dense, more local, finite, and may I add, suspiciously young. And he's
Yeah,
correct.
we talked about
You
that
could just
quote.
make those correct. Well, you could just make all those corrections. You
Sure.
can bring everything closer, make it smaller, make it more dense, make it finite, and then you're good to go.
Yeah, but Hubble wasn't talking about. He was talking with reference to like an infinite universe, right? Anything smaller than that is going to be suspiciously young and local.
But the point is, there's no
Like,
limit on it, right? Like you can just keep bringing it in. Like, it's just a proportionate relationship, distance and size.
yeah,
So it's like,
but at some point you're going to butt up against like other observations that just don't sustain that.
You'd have to name one because I vehemently disagree, and I don't think that you're going to be able to name one.
Stellar parallax, like across
What about it?
seasons.
Stellar
Why would
parallax
that
In
works
be?
terms of
perfect.
stars,
Stellar parallax
unless
works
you say
better in a
light,
geocentric model.
unless you're saying that light is doing something differently.
No, it's just inside of an ether in a fluid medium, and the sky itself rotates, so it has an angular momentum.
No, it's not
Does
just the
that go
rotation.
for radio waves as well?
What
Yeah, why
about
would
radio
not?
waves?
Yeah, it
Radio
would
waves
just
are
You
be
can
light.
use
I think
radio.
you know
You
that.
can use radio waves for doing parallax.
For doing what?
it would just
Oh,
be electromagnetic radiation.
Parallax.
so what?
Okay, bro. You realize this is very simple, right? Like, okay, what is stellar parallax?
So as we go from one side of the orbit to the other side, we can look into the distance and see some stars are shifting more or less. And we've come to the conclusion, I'll try and be as level-headed as possible. We've come to the conclusion that that's due to the perspective.
Okay, you just kind of presupposed and begged the question, right? By starting it off by the other side of our orbit. But I'm asking, what is the observation itself? Like, I'm not asking what
So
your explanation of it is.
Yeah,
Like,
yeah. No, I'll take all of
yeah,
that out. Yeah. So in neutral terms, 6 months apart, we look at the same star and the same set of stars in the distance, and we see some of them shift more than others.
okay. So we see the stars shift.
Yeah, in a
Okay,
way that
so,
seems consistent with perspective.
so we see the stars move, and in your model, it's an illusion because actually it's us moving, creating the illusion that the star moved. The alternative
Uh,
explanation would
mhm.
be we see the star move because
Uh-huh. Well, you'd
good.
have to fill that in.
The
The
star
alternative
moved
Because the
explanation
stars
is
are
because the
moving.
star moved.
yeah, but there has to be some, like Newton's first law, right? There has to be something moving it. It has to
The
come to a
universe is
stop
moving,
and then
bro.
turn around and move the other way.
The universe is moving in a giant circle as angular momentum. And even the distant galaxies complete circular rotations once a year.
Yeah, circular motion is fine, but we're talking about stars that go back and forth, right? Within the background of that rotation, like there's things that shift left to right depending on what month it is.
The way that we're claiming that they shift back and forth, it's relative to the background.
Yeah.
It's relative to the background or whatever's around it. So for example, if I had two things, one thing moving in front of the other, right, and then that thing started to slow down and the other one didn't, you would say that one went backwards, but it didn't. So the things
Yeah.
in the sky are moving,
Mhm.
maybe slowing down and speeding up based on the angular momentum and where they are within the vortex. They can just slow down and speed up, for example. They can just shift on their own.
I mean,
We see the star moving and
I'm
you're
not,
claiming it's an illusion.
no,
So,
no,
I
no, no.
mean,
I contend that terminology. Optical phenomenon at most, but I wouldn't say illusion. Illusion happens in the brain. Either way, it's the same sort of issue that you have with retrograde motion, right? If it's the actual star doing that, like what's making it come to a stop, turn direction, and then come to a stop, change direction, keep going back and forth. Like it's not
okay.
just an optical phenomenon. There should be some sort of force doing that, right?
What? There is a force. It's the angular momentum of the universe itself. There's centrifugal forces, there's centripetal forces that all exist within the rotating universe itself. It would actually move perpetually because of this, because you would have twice the magnitude of the centripetal force. It basically balance out like a celestial seesaw. So it's just going to keep spinning. You have stars within this fluid medium that's moving within that, right? And super fast, honestly, depending on their distances. And then they just are within an overall cycle where they shift.
But you
Why
would
would that
agree
be
that
a
it's
problem? Like,
simpler. you would agree at least that it's simpler to have all the planets rotating around the sun, right? Even if the sun is rotating around the
No,
Earth,
no, because stellar
that doesn't
parallax
make more sense
again
to you.
is just the apparent annual shift of nearby stars against the distant background.
Right. But due to what? Like you're saying it's just the stars moving in that way themselves.
Yeah.
I've not understood the mechanism you're proposing for that.
You would just have like
Mm.
an angular deviation within the motion relative to the background.
How did the Earth
What
start
is
spinning?
I'm not getting it. I don't know. It looks like any other kind of
That's why
parallax that we
everything's
see
moving in
based
your
on our own
model.
motion.
it would just
Yeah,
be a
but it's moving in a
tiny
particular
annual
way.
oscillation within the angular momentum with an angular deviation around a stationary Earth.
Sure, I'm
What I
granting
don't
you that. I'm asking the mechanism for that. What's causing this thing to oscillate?
the motion itself.
What would prevent if we
Uh,
know it's moving around? What would prevent it from moving in different ways?
Newton's first law of motion, that if something's moving in a particular way, it's going to keep moving that way. What we see is that it moves in a certain direction, stops, then moves the opposite direction, stops, and goes back and forth. Like something's causing it to come to a stop and change direction, and then come to a
Do
stop
you
in
have an
that direction.
example like retrograde? Is that what you're talking about?
It's something, yeah, like retrograde motion.
I mean, the way that things move in the heavens, I mean, anybody can speculate on it. I don't think anybody could say definitively, and to say that you would know exactly in your model either would just be speculation.
I
You could
think
say
that
that. I mean, we have good reason to think what we think, right? Like
Like what?
whether we've got it correctly right or not, it is based on a good amount of like other sort of uh, demonstrable hypotheses
No, it's
What is the
not.
demonstration
of what specifically.
of what you just said? You said there's demonstrable hypotheses. Can you give me an example?
Yeah, the way that science builds on previous knowledge is what I'm talking about, right? Like we have certain basic fundamentals that we've established, and we build on that, and where we've gotten to now is why we think the world works the way it does.
so.
I
You're
mean, you're just
demonstrating.
hypothesizing a model.
I
Okay,
think
dude,
the
let me
proposition with
let's
the.
just I just want to
Sorry, go
rewind
with.
because I think wait. I think it is a good question, right? Like the stellar parallax is interesting, but all we know is that there's a slight shift relative to the background, right? And it oscillates. And you're saying that I need to know a force. We don't keep that same energy for all the stuff that you can't explain, like dark energy and stuff. It doesn't matter. Whatever. Okay. Like there's a couple things that I just hate to speculate like this, dude, but it's like we know it's in relation to the sun. You think that we move around the sun once a year. So obviously we can flip that around, right? The sun moves around us,
Hmm.
right? And then these planets seem to move in relation to it. So it depends on which geocentric framework you actually adopt. Like if you do a neotychonic framework, then you would have like the planets moving around the sun. The more local stars would be closer to that sun. So say that there's a magnetic field of the sun or some type of coupling effect with the more local stars, and that would actually cause it to slightly oscillate and shift annually relative to the position of the sun.
That only
So there could
happens in planets, though. Stars do not do retrograde. I'm not sure why you'd even posit that. Like,
we're not talking
fixed
about
No,
stars move
retrograde.
they just
steadily
have.
across
Talking
the
about
sky. I know, but I think that he just posited something that's not even really happening
The planets do
and
It was
asking us to
retrograde.
a
fix it.
yeah. Planets do retrograde. Their stars do parallax, but
So what
the
are you
notion
talking
of
about?
coming to
It's
a
like
stop and turning
moving,
direction
stop,
is the same.
moving, stops, and moves
you
again.
can do one
Yeah,
can do
the
quite
Wait, hold on.
accurate
I'm talking to
parallax without.
Manufacturer real quick. I just want to ask him
yeah
one question.
Taylor.
Yeah.
Yeah,
Yes.
so
Manufacturer,
super
This
quick.
the
I
why
can, I
wandering
can
don't I have
planets,
the
explain
the
it
right to
super
wandering
ask
quick.
him a
stars
question?
appear to retrograde in the sky. So they'll go forward,
Yeah.
and then they'll go back a little bit, and they'll go forward, and they'll go back a bit. That's what I think Manufactotum Totem's trying to hint at, as far as like,
Planet. But he
Yeah,
was
and
asking
the
stars.
and
a
stars
wandering
have
star.
parallax.
Okay,
Stars have
stars
parallax.
do
Yeah,
The
not.
same sort of
like
idea
for
of going in a direction, coming to a stop, and oscillating.
Okay,
Like the
stars don't
motion is similar
do
between the
that.
two.
yeah, they do
No, the
because
planets do.
if you do that measurement and you see like the further away, the further star is moving in relation to the closer star during the year.
But they're not
So the
stopping.
angles there do change, so they move back and forth.
You didn't say this, that's why I'm not asking you. I'm asking Manufactorum. But yeah, I don't know. I just wanted him to know that stars do not do like the retrograde thing that planets do.
No, but the notion of
Not that,
going in one direction, stopping, going the opposite direction, stopping, like that's stellar parallax when it applies to stars,
You have an
is similar
example?
to
Like what?
retrograde motion.
I don't think so.
I could
Like,
probably find a couple.
Yeah, the
please, 'cause
planets.
I'm not sure what you're talking about.
The planets retrograde in the sky, they move forward and then they go back a little bit, but you can actually draw like sort of flower of life symbology on on the AE map, and you could see like them basically forming the same pattern and structure.
Stars
You familiar
don't
with
though.
that, Taylor? No, the planets.
Okay, that I get the planets do. Like I'm totally on board. I think he was just asking about the stars and positing they do that. Anyway, we can move on. He was just asking like to explain something I don't think really happens.
Okay, well, yeah, the stars look like they slide a little bit and then like slide back when it spins back is what it's
So
like. If you look at the time lapse of the stars, like it does look like they kind of move. A couple of the more local, quote unquote, local stars seem to kind of move. They're calling that stellar parallax, claiming it's based on our orbit. But if you were in like a giant vortex and there was like a rotational, like angular momentum, then say you're looping around one of the spins, like where it turns its curve, basically, right? Then the more local star can shift a little bit, and it comes back around and loops back around inside the vortex, right? It banks in a way, like it curves back around and it shifts back and it just keeps doing this over and over and over. And just for the more local stars that is closer to the center of the vortex motion. And I will
Yeah,
mind you that
compared to
stellar
this.
parallax is super hard to actually observe. The resolution, the resolvability is super sketchy. You wouldn't know if things like this happen in a progressive way further out because the resolution needed to observe it is not something that we can attain at all. Certainly with atmospheric turbulence and stuff like that, which is well known and acknowledged. And I have a Harvard paper discussing astronomical observations, specifically parallax, and admitting that we really can't even resolve to what is needed to measure a lot of this parallax. And so sometimes you'll accidentally get negative parallax. And it says in the papers, the official instructions of Harvard astronomical students to just treat the negative parallax as positive, to just flip it and make it positive because it's close enough.
but you
You
can
see a
do,
shift.
but you can't do, you can do parallax over quite a long distance without using the Earth's orbit around the sun, like by VLBI. Where you have like radio telescopes from the South Pole to Svalbard up in north. You got in Hawaii, in Japan, all over Europe, and you combine these as one giant telescope, and you can use
and
that
just for the
to
sake of
do parallax measurements to radio sources. So then you don't need to have, you can do it at, let's say, within a couple of minutes. So you don't have to take the Earth's orbit around the sun into account. And still, they measure quite long distances rather accurately.
so
Yeah, I'll just
Taylor asked a
reiterate
specific
this, right?
example.
Like they claim that the stars, even the really close stars, that parallax, it's like, what is it like? Couple tenths of an arc second or something. And if you actually look into the technology that we have to make the observations, the reliable resolvability window is much less than the parallax claimed, which is why the Harvard astronomical papers and instructions for their students tell them that sometimes they'll get a negative, just treat it as a positive. So
Yeah,
you guys
well,
always
the
omit the part
VLBI,
where it's like a couple tenths of an arc second and that the
yeah,
resolvability of
VLBI
telescopes.
the VLBI can have down to a few milliarcs and arc second accuracy.
What's the acronym? that you're using?
VLBI has an accuracy doing parallax down to a few milliarc seconds.
What's the acronym that you're using?
Very long baseline radio interferometry.
Okay.
The one they use to make the image of the accretion disk around the black holes, same system. So you don't use light; you use radio sources.
Real quick,
So-
just because
apparently we
Taylor
don't
asked for a
receive many
specific
radio
example,
It's
the closest star to us is supposed
let
to
me
be
know
Proxima
whenever I can
Centauri.
go. Thank
So, yeah, just because you asked earlier, Proxima Centauri is supposedly the closest star to us, so it's the one you see the most stellar parallax with. I posted two. They were supposed to be GIFs. One of them's not moving, but one of them shows what I'm talking about in terms of stellar parallax.
Yeah, I've seen the gifs for sure.
Okay, so this is like a shift in position of nearby stars against the background of like distant stars. But they're not like
Right.
stopping in the sky or ever moving like west to east. Ever. Like this is like an apparent wobble that happens over 6 months. So it's not like some stars like stopping, moving backwards, and then it keeps going forward as it was like appearing to be described earlier. So yeah, this is a tiny wobble over like 6 months compared to like stars in further away or in the back, whatever they call
Well,
it.
that's what we already said that. Yeah. But
Okay,
like
yeah.
the point,
So my question is, what's causing the wobble?
yeah, and then it goes
Okay,
back.
but stars aren't
goes
like
back-
moving backward in the sky. Anyway, go ahead.
Well, they shift back and forth. That's the point. The back is just that they go back and forth every 6 months.
Like a wobble, but they're always moving east to west, you know?
Of course, yeah.
Okay.
It's like an
Got it.
oscillation or a wobble or whatever. He's asking what would cause it. Because when it comes to any replacement of their belief system, they need exact, precise, knowable answers as opposed
Not that
to
precise.
dark energy,
The
dark
fun-
matter, inflatons, and whatever other magic thing. But
Yeah,
I explained.
you understand we're very uncomfortable with the dark energy, dark matter thing. Like we're
No, you're
desperate to
not,
solve
dude.
those.
Every other person I talk to acts like it's not a big deal at all. And they just say it's the cutting edge of science. We don't have to know, but we know we're still right and we know it's there. And like, they're not uncomfortable with it at all.
They are. They're
Well,
happy
then
to
they're
have
they're
questions
just
that need to
dishonest.
be answered. No, they're happy to have questions that need to be answered, but they're not saying like this thing disproves totally just because we don't know yet.
But you're not happy to not have this question answered, right? It needs to be answered or it's the orbit. But the point is, I am kind of answering it. So I did
Kind of.
answer it. Well, I mean, it would be a simple oscillatory byproduct of the angular rotation itself. I would expect the stars that are closer to the center of the vortex to shift, and it makes sense that it would be quote unquote 6 months apart. Well, that would just be half of the rotation, right?
So it sounds like you're saying it is some kind of parallax, just not the kind of parallax we think it is.
Well, if the Earth's not moving, then we would be seeing the star move. And you think that we see the star move, but it's an illusion. Like it's pretty simple.
Optical phenomenon.
But it could be
Illusions happen.
it could be an optical phenomenon even within the geocentric universe, right? Relative to the background. So it's just a small annual wobble, right?
But it is there.
Well, I'm yielding it being there. I have since the beginning. I jumped in to make the
Sure.
point about parallax because it's like the confidence that people talk about parallax of all kinds of stars is laughable. And when you actually look into it, nah, bro. Like it's not. Most of the observations that are claimed to show parallax, we can't even reliably make the observation. But I'll
Yeah, I
yield
mean,
the
there's a
close
limit
one, like
to
the
how far we
GIF or
can do
whatever. Okay.
No, that
So
was
the
it.
stars are making like a little loop, right? And the little like ellipse, basically, like the shape makes it like an ellipse. In a geocentric universe, it would just be a real motion of the stars. And in the heliocentric idea, the little ellipse would just be an apparent motion, an apparent effect based on the observer's motion. It is actually that simple.
So you're saying the star that we perceive as having parallax is like rotating out in the distance, like orbiting something?
Wait, what?
You said it's it's an ellipse.
Yeah.
That the star is doing?
Well, yeah. If it's going around us, it's like an apparent little ellipse. If it slightly shifts.
If it's an ellipse, then of course the angular separation between the stars should change. Well, from when they are further away and until they are closer away. So the angle separation between the stars should shift, but they don't.
What? What? No, it shifts back.
I
It
don't
just
think
goes
he's
loops
saying.
back around.
No. The distance between the stars, if they are rotating around the Earth in an elliptical orbit,
I didn't say that.
the distance between the different stars should shift
I didn't say
from
that.
aphelion to from where they're furthest away until they are closest to us.
Yeah, I don't think he's
Okay,
saying
I
the
didn't say
whole
that.
body of
I don't
stars
think.
is doing.
Okay, sorry, I misunderstand you there.
Yeah.
But what
yes, you
about all
did.
the other
Thank you.
methods then? But what about the other methods which sort of supports the parallax? I mean,
You
Cepheid
mean all the
stars,
other
standard
methods that
candle,
show that the
stand,
stars move and you think it's an illusion?
no distances. Cepheid, I think it's called Cepheid stars.
It's all going
The
to be the
standard
same answer,
candle,
brother.
the standard candle measurements, the type is it 1 or 2 supernovas?
Type 1A.
Which
Are
can
we talking
also
about
be used,
supernovas
which
now?
also can be used to calculate the distance to stars.
Oh my goodness. If you got a list of things you want me to answer, you can type them up with some type of
No,
specificity. I'm
no,
happy to look through
it's
them.
just there's a few other
All
methods
right,
which
dude.
sort
Like,
of
you see why I don't
correlates
feel
quite
compelled to
nicely
answer you
to
when
the
you
closest stars though.
stomp all over me.
And as I
Okay.
mentioned, the VLBI. How do you explain the VLBI then? Where you can do you don't depend on the movement or orbit around the sun. You can just do these measurements over a few minutes.
I have a question.
Where you have accuracy.
Why would
Before we
that be
move on to,
exclusive to us moving?
No, I'm not talking about moving. I'm talking about distant parallax distances.
I
Okay,
have a
why would it
question
be
about that.
exclusive to us moving?
I'm not talking about movement
Okay,
at
so it
all.
wouldn't be. All right, well,
So
cool.
even if the Earth was stationary, these measurements you can measure quite accurately for really long distances using the system.
Okay, so now we're shifting to overall. Taylor, do you have a question before I address?
Yeah, I
Yeah,
was just
Taylor,
gonna
what
ask,
was? Yeah.
is it because the Earth is moving so like the position of the Earth is changing and this is why the parallax is happening? Because the Earth's getting
Not to
like
do with the
closer and
VLBI.
farther away from these stars?
Yeah, what they claim
You
is
can
the sun and that we're
you can
viewing.
do that with VLBI, and you can continue during the day. So you see how, especially from radio signals for quasar, which is when it comes to reach us, it's like a straight horizontal line coming towards us, and the let's say the northern and the southern telescopes receive that radio signal later than the ones in, let's say, in Europe and in Africa. So that the exact same radio signal has to travel further, which in
Okay, she
fact
was asking.
is another evidence that the Earth is not flat.
I got
Oh
a
God, you're all
question.
over the place, dude. Like, do I actually like one point?
No, but just go
Don't you
ahead.
guys
But
think it's
just forget
super
that.
funny that I dumped
VLBI can
so
be used.
hard on
Yeah.
their model that they're having to like shuck and jive for any random hyper
Well,
specific question? Like, bro, I'm just saying it's very telling that it always comes down to stuff like this. Well, then, like, instead of conceding that like all the major issues in your model isn't an issue for ours and we dunk all over yours and ours is way more viable and superior in almost every conceivable way, it can actually provide viable causal mechanisms that can be replicated in the lab, as can the geometric manifestations of the galaxies themselves. We can replicate all of it, show it all in a lab, it's consistent with the spectroscopy readings. It's literally superior in every conceivable way. And instead of acknowledging that on
So,
the
and
mass
how do
scale,
you measure the
it's like, let's
distance to the stars?
scour through the insanely long list of hyperspecific astronomical observations, flood our question with a ton of presupposed reification fallacies that we're incapable of separating from a geocentric universe, and then ask you to explain it and fully replace it based on a lot of my unfounded pseudoscientific answers I've been fed, or somehow all the other stuff isn't true and goes away. I just got to make the point that meta point there. It is pretty funny, right? Because like if
Yeah,
my
but
position was so laughably wrong and easily refuted, we wouldn't be getting all in the weeds every time the conversation comes up. You would just be dunking on my position, and realistically, you can't. The geocentric universe model is far superior to your model. It's not even close.
I don't
so
think it's
how do you
laughably
measure the
wrong,
distance to
but I do think it's
stars?
fundamentally flawed.
I
Yeah.
think it's fundamentally superior, right? Like I think the causal mechanism itself is superior. I think the composition of the universe is
But you don't
superior.
have
I
that
mean,
though.
we do,
You don't
we
have
do,
the causal mechanism. You have an
we do.
explanatory model. You have,
E-
but you don't have anything
Everything's
that
Neither
says
magnetic.
do you.
what should change the. We do. We have the fundamentals where we break down is on the edges, right? When we get to like galactic scales and dark energy, dark matter. But what Witsit is missing is the what causes one thing to have a particular. I don't want to say charge, but to have a strength of attraction comparable to another object that should, in theory, not have a different charge, right? Like
What?
what's
No,
causing that to
you
look
keep
the same as what we see
misunderstanding it.
today?
It's not about charges, man. Why do
I
you keep
know I
bringing
didn't
up
want to say the
charge?
word charge, but I know you relate it to magnetism. I don't know what to call that, so I'm just using
There's
a
magnetic attraction, which technically there
yeah,
is no such thing as magnetic attraction. It's actually acceleration to the null pressure point between the two. Like if you take two magnets,
yeah. That's
they actually just accelerate towards each other because there's like a null little zero pressure point between the two. So they migrate there, right? They accelerate seeking equilibrium due to pressure mediation. But we can use
sure.
magnetic attraction for intensive purposes of
Yeah,
the matter.
that's all fine. My question is what causes things to have the specific rate of attraction that we have for all this time confused with gravity.
You don't
That's
even know
what
how
you're missing.
gravity works on the atomic level, dude. Like, why are you gonna like
Doesn't
demand
matter.
this from
Don't
someone
need to
else?
know on
This
the
is so
atomic
ridiculous.
level. That's
It's a
Huh?
double
irrelevant
standard.
to any of this. We don't need to know how it works on the
What? You
atomic
don't even
level.
know how it fundamentally works, and you're sitting here asking someone else to like describe it to a T. Are you kidding me?
No, I'm not. I'm asking for the same
What?
causal mechanism that we have. We don't have
You don't
how it
have a
works on the
causal
atomic
mechanism for
level, but we
gravity,
can tell
bro.
you. Yes, we do.
No, you
No,
don't.
no. What I'm
Yeah,
saying is
where
even no,
does it
you
come
literally
from?
don't. Like if I look,
You
if I
literally
assume
do not.
gravity and look up at the sky, it doesn't work at all, bro. But magnetism would work. You're asking me how it gets there? It's like, what? It's simple. You have plasma, you have a fluid medium, and you have a magnetic field within it. And you're asking me how magnetism
So those
works,
are
basically. It's like, okay, well, I
okay.
can tell you
Great.
it's an etheric expression. It's an etheric modality. You have a geometric expression of a field of force. That's all it is. You have the ether that's
Okay.
basically excited. You think it a conjugate geometric expression, which is a fancy way of saying two sides to the same coin. You get hyperboloid and
Sure.
toroid. It's geometric expression within
Okay.
the magnetic field. You have centrifugal divergence, centripetal convergence, and it's the only truly autonomous field of force. That's it. It's perpetual exchange of energy. It just loops in on itself
Okay.
over and over. And the center is basically a portal to the ether. It's pure inertia.
So if you're basing this on that, then you're under the same problem that we have if you say that we're just presupposing certain things and building off that. Because as far as I can tell,
Uh,
a lot of this causal mechanism you're putting forward hasn't actually been demonstrated.
it's a magnetic field. It absolutely has been demonstrated. So your model doesn't explain magnetism properly. What it does is
Mhm.
it uses like electrons and photons And then when it adds it all up and gets the total energy, it doesn't have enough. So what they did,
Sure. So
instead of
your
being
model
humble and
hypothesizes.
instead of actually being scientific and being like, okay, our model sucks and our theory is clearly wrong, what they did instead was fabricated some new particle that they could plug in. And if they plugged enough of them in, then it would account for the missing energy. Virtual photons are like magnetism's dark matter. They plugged it in and then they matched the amount of energy being read. And then we were able to take that new equation with the virtual photons in it, and we were able to predict magnetic phenomena going forward very precisely. So we can very precisely map out magnetism, and we can also know the distribution of quote unquote electrons and photons within it and the exchange of virtual photons within it. The question comes down to, well, what really is a virtual photon? It's merely a concept, it's a mathematical fix because you have localized excitations from the background medium of the ether that simply can't be accounted for within your materialistic framework. That's all it is. And so we can set all that aside and we
You
can
said the
even
same
just
thing.
use the virtual photon idea. We can use the virtual photon idea because it doesn't matter. We know magnetic fields are a real thing. We can replicate them. We can map them out with extreme precision. We know that they have multiple manifestations. They have rotations and counter rotations. They have vortices. We know about magnetohydrodynamics and how it interacts within fluids. All this is well established and known physics. I'm just taking that,
But it doesn't.
I'm putting it in
No,
some
what you're talking
plasma,
about isn't
and it's
well
creating
established and known.
galaxies.
That's my point.
Everything I'm talking about
The
is well
plasma that
established
you're
and
saying
known.
is out,
And don't
but
monologue.
not the way you say it works. It doesn't work the way you say it works, not according to standard science. The reason you have
What doesn't?
virtual photons is an exchange of energy that makes sense with the observations, right? Whether that thing is
No,
real or
virtual
not,
photons
there's
don't
some
make
exchange
sense.
of.
They don't.
Well,
Don't know
anyway,
how
you
it works
talked so long, I
either.
forgot what I was going to fucking say, so I don't.
Okay, bro, you understand virtual photons aren't a real thing?
Yes, I understand they're not a real
Okay.
thing. That's not my point. My point is you're starting from a premise that you're saying we don't understand how magnetism works. And then you're proposing a hypothesis on how magnetism works that, as far as I know, has not been actually demonstrated.
No. My explanation doesn't require to fully understand exactly how magnetism works, right? As
Nor
in the
does it
primary
ours.
causal. Yeah, no. The difference is we're gonna grant your theory of space-time for a second, okay? And we're gonna grant magnetism, okay? The difference is I can replicate and manipulate magnetism in a lab. Yours is simply conceptual. That's all it is. Doesn't matter. We're going to now apply them both to the sky. Mine is 1,000 times better than yours. I do not have
Well,
the problem
no,
of
because
dark
yours
matter.
requires
Let's use
everything
the
to
coma
be.
cluster. Let's use the coma cluster as an example.
Hold on,
There's a
just
little
super
cluster of
quick before
galaxies.
you go on to, before we get off on that, real quick. Yours also requires everything to be much more closer, right? So I
No, it
wouldn't
doesn't
say, strictly
require
speaking, that
that.
yours is
It doesn't
better.
require that. That's just what I think the obvious answer is. And the only reason that the stars are so far away is because of the heliocentric globe assumption. We put the stars super far away because if the Earth is actually moving, then we would see way more motion in the sky unless everything was super, super far away. Also, if the Earth was actually a globe, we would see way greater change in positioning of the stars unless they were super, super far away. So we had to throw the stars at infinite distances to assume the Earth was a moving globe. And then we had to be like, wait, if they were really that far away, how could we even see them? The only way in theory we could see them from that far away is if there's nothing in between us and them. So then they theorized a vacuum. Okay, I don't have to make any of those assumptions because I don't believe in the moving globe. So now I can just have them be closer in a fluid medium. I don't have to have them closer. I just can have them closer. And it's obvious that they are closer. The distances that people have attributed to the sky are ridiculous, right? And no, it's not a pill to incredulity. It's just a challenge.
It
Prove that something
literally
is.
is.
No, it's not. You claim a star. How far is 5.88 trillion miles? You can't even conceive of that. Now multiply that by 46 billion, and you're claiming to know a star is that far away? No, you don't know that.
Roughly,
It's
yeah.
just 5.88 trillion times 46 billion miles away. That's insane. So, I
It is.
mean,
It's
in
quite
theory, is it
counterintuitive.
possible? Sure. But I don't have to yield it and grant it and pretend it's true. You don't actually have evidence that it's true, right? You have no
We
evidence
do
that it's
have
true.
evidence. We might not have
No, you
proof
don't.
necessarily, but we certainly have evidence.
What's the evidence that a star is 46 billion light years away?
All of those things that Stefan rattled off, all of those different techniques that we use to measure the distances to very, very distant things. They might not be exactly precise, but they give us good approximation.
Dude, nothing that he invoked is going 46 billion light years away. Yeah. So
Well,
the other,
quasars. What's the distance to the furthest quasars?
oh, I don't know. 46 billion light years away, from my understanding, is like the edge of the visible universe. So I brought it up because it's like the furthest claim made. Quasars are a whole nother problem for you though because of redshift and they don't work within your paradigm at all. But like,
You don't see single stars at that distance. What you see is galaxies, big
sure.
objects, hardly
Well,
single
whatever.
stars.
Whatever, there are stars in the galaxies, doesn't matter, right? Like you believe stars,
Yeah,
galaxies, whatever, are 46 billion light
but
years away.
how close do you think the closest stars are to us?
I don't
Dude,
really
what
know,
the heck?
man. I have no
And
idea,
what is your
man.
evidence that any stars are far away? You said that he rattled off evidence manufactorum. Can you please tell me?
V-
'Cause I didn't hear any.
VLBI is one way,
Radio
What?
which
interferometers.
is really
Radio.
Dude, we can't even like receive like many radio waves like here on Earth from ground base. We can from like certain objects, but why would that even indicate that like it's a billion light years away or whatever?
This
Parallax.
conversation is going to get into some sticky areas because a lot of what we use is actually done on satellites in space away from the atmosphere. And I feel like that's going to bring up a whole bunch of
Yeah,
other
it's just all
contestable
pseudos. It's all
I
issues.
know, and I was gonna
pseudoscience.
make a point on that. Like Polaris is supposed to be within our like galaxy. Like, why doesn't it like do any parallax that's observable from like any ground-based observations? And apparently, it's just like they say it happens, but they're like, oh, well, it's only so tiny that like only the satellite-based telescopes can see it. Okay, that's great. Like only like
Why is
5
that?
stars, if that,
Well, why is
can
that a
even be
ridiculous thing?
detected from like ground-based astronomers, because of from parallax because of like turbulence and stuff in the atmosphere. They say so. This is like so speculative. I mean, we just have to rely
Why is
on these
that?
like. Why are you like constantly interrupting me, dude? I barely talk, and I'm very quick with what I state.
Sorry. Go ahead.
I'm just saying, like we have to rely on them for these claims. But yeah, can you explain the radio waves in a billion light years away?
Not if you don't concede that satellites exist. No.
Well,
Okay, but
VLBI
in your satellite paradigm, how do you determine
no.
they're billions of light years away or millions or whatever from
I
like
think he
these
was about
radio
to
waves?
say. I think he was about to say that he's invoking something that doesn't require deep space satellites.
Yeah, VLBI does not require. Those are Earth-based large radio telescopes.
Yeah. Do you want to explain? You want to kind of like explain what it does and how you know and like what's the like maximum distance it's supposedly confirming?
If I remember correctly, I think the maximum parallax they can do is about 10,000 light years or something like that.
10,000 light
Wait,
years.
so you said radio waves. Can you explain the
yes,
radio waves thing?
there are quite a few. Have you ever seen telescope images, radio telescope images of the sky?
Yes.
Yeah, there are plenty of radio sources out there. I think the biggest
Okay, so
radio
how does that
telescope,
equate to billions?
the biggest radio telescope today is the Chinese one, which has a diameter of 500 meters. So it's extremely sensitive, and so are the other ones are really. So what you end up having is basically sort of what's it called again?
What'd you say the acronym
It's
was?
like it's like a radio telescope at the size of one side of the face of the Earth. It's
Okay.
enormous large. Yeah.
Wait. So
They
how does that? Okay. Go ahead.
and they have figured out the known distances between the different telescopes are down to a couple of centimeters error margin. And the radio signals coming in have like amplitude and stuff, so they can identify the exact same radio signal, and they can time it when it receives the different radio telescopes. So you can not only do like parallax, but you could also do use it for like a Earth's reference frame, which it is in fact today. That's the most accurate measurements of Earth's reference frame there is. So you can use far off radio sources to use this gigantic telescope to do parallax measurements.
So only from parallax do we know that stars are XYZ far?
No. Cepheid stars, standard candle, type 2 supernovas?
Type 1A.
In addition, and then you have 1A, yeah, and then you have the redshift, which correlates with this.
So
there's quite a few ways of doing this.
I have a question for you. Sorry to interject for just a moment.
Go ahead.
Can radio waves be transferred through a vacuum?
Why not? It can.
Yes.
You can send it through.
Answer a question with a question, please.
No, yeah, it can.
Okay. How is that possible when the functionality of radio waves requires some sort of a medium to travel through, not a vacuum?
Not electromagnetic. Yeah. The electromagnetic field. It's not like waves in the medium.
I mean, you could call the electromagnetic field a medium, I suppose.
what is that?
Yeah, you probably could.
So we
Okay,
do acknowledge an underlying medium to space?
No one denies the electromagnetic field permeates everything. Like,
Okay,
if
so now
that's
we've
what you're
called
calling the
ether like
ether, I
an
don't think many
electromagnetic
people would.
field?
Well, no, you're calling the electromagnetic field an ether. I think if that's all you're
Either
doing, most
way.
physicists, I think, would kind of be okay with that. But it would still have to function as they know it functions. Right?
What
It
is
still
it
wouldn't be
made
doing
of?
a lot of the things that I don't know, honestly. Virtual particles, maybe.
Okay, so I was asking a fairly complex question, which I have not received a sufficient answer to at the moment, but here's another one. Can sound travel through a vacuum? Is this easier?
No.
Oh, okay. So the more complex question, which I just asked, was radio waves. They can travel through it, but sound can't.
Correct.
It makes no sense at all.
It makes some amount of sense. So they're both vibrations, right? It's just different things are vibrating. For sound, you need physical matter to vibrate, right? Some, I don't remember the kind of compression waves, I guess it would be. And electromagnetic vibrations are vibrations in the electromagnetic field, which you can't get rid of in a vacuum.
Okay, so you're inferring at this point, I'm assuming you're inferring that there's some sort of background magnetic radiation of some sort, and that's how the sound waves can't travel through, but yet the radio waves can. Am I getting that right?
Something like that. Yeah, something like that. Yeah.
Okay.
I mean,
So
what is this field? And yeah, maybe like Stefan, if you have like a particular example with the billions of light years away thing, you can just share with me. Like the only thing I gathered from what you were sharing was like parallax. And then in terms of the radio waves, Like, I'm not sure what they're calling, like, the electromagnetic field. So if y'all have, like, anything on that, just share it with me, please.
Yeah, I'm not really sure. I just have to, I think, try to clarify in case I'm confused about what he was positing. It's the background magnetic radio wave, something or other, caused by the Big Bang, and they say they can see back in time because of it. Is that what you're referring to?
The CMB.
Yeah, cosmic. Okay.
Okay, but wait, real fast. So with the VLBI, right? That stands for what? Very long baseline interferometry.
Yeah. Yes.
Okay, and so you have two different like receivers on the Earth.
No, there are many of them. From the
Okay.
South Pole to the way up in the Barents Sea, spread over Europe, the US, Hawaii, Japan, and so on and so forth.
Okay, so what they just compare, like, do they use two at a time or they use a bunch at the same time?
They can use two, they can use several.
Okay. And so they look at, like, say, a quasar, they receive the radio transmissions, they observe the radio transmissions coming from that direction. Then they try
Yeah.
to isolate the ones that they're receiving to be coming from that specific thing.
Yeah.
And then they compare the reception time with like
Yeah, that's
immense
what way up.
precision.
Yeah.
And
Yeah.
of course the radio
But
waves.
that's not basically parallax though. That the timing of those signals are used for the Earth's reference frame.
How could they ever know that they're for sure receiving a radio wave from like that quasar out of all the radio waves that come from the sky?
Because when they point the telescope at that specific source, they receive the same radio signal.
Wait, what does the timing say about the distance? What were you saying about that?
Well, they're going to take the
No,
speed of light.
timing has more to do with Earth's system.
Okay. So parallax? That's all you use for
The
distance?
parallax is done in another way. That's the angle. You can have one of the telescope up on Svalbard, which is way up in the Barents Sea, and you can the telescope at the South Pole, and you can point them at the same source, and there you have a parallax measurement.
Wouldn't that only say how far apart those things are on Earth?
You know the baseline distance between the telescopes, and then you measure the angle to the objects in the sky, and there you go. You have the baseline. You have two angles, and you can the distance to the object.
So one of them sees it before the other? Is that what you're saying?
Yes, very often, yes, but that doesn't matter. It's such a short time difference, so there won't be much change of the distances or affect the parallax that much anyway.
Okay, so then what are you using to determine the distance to a thing if they receive it at the same time either way?
You have a baseline, and you have two angles. That's all you
Mm-hmm.
need for doing parallax.
Okay, so like with parallax, couldn't you have like the same effect with like closer stars? You know, like if everything was like scaled down to a closer version
Well, you know
and maybe it was
the
larger
baseline.
or something?
But you know the baseline. So if the star were closer, the angles would be smaller.
So the only way that we know the distance to stars is from parallax?
No,
I was trying to ask for like another example because I'm trying to like. Go ahead.
CPI stars. I'm not quite sure I'm pronouncing that correctly.
Wait, you said I'm
I
gonna
think
type it in.
it's
What did you say? VPI?
CEIH.
I think they're called Cepheid variables.
Yeah, Cepheid variables, which even Polaris is. And then you have what they call standard candle. And then type 1A supernovas.
What about it?
Those can be used for calculating distances.
So we look at like a type 1A supernova. What about it would say that it's a closer distance or a further distance?
The intensity of the light coming to us.
Couldn't it just be a smaller event than we think it is?
No, not really.
Why?
Because at least the mainstream model, the star to become supernova has to have a certain specific size. Like you probably heard about Betelgeuse in Orion. Yeah, that's the enormous star, which might go supernova even in our life.
Hold on. Okay. I know what you're talking about, Betelgeuse. It's a very, very bright illumination in the sky, and I wasn't aware that it was part of Orion. But anyways, if I use parallax with anyone else on Earth that can see it at the exact same time, therefore, I could use parallax calculations with every other celestial object in the sky, and they'll pretty much be the same thing. And I have plenty of videos and photographs that I've taken myself.
No, to get a stellar parallax, you have to use the diameter of the orbit of Earth.
Oh my gosh, I was just trying to talk about something simplistic and not go off on.
Well, for stars, they're so far away that you can't do it from just on Earth with a pair of observers. For that, we can do things like the sun because it's much closer.
How do you know how far away the stars are?
And I'm looking for a
they've
raw
been looking
video
into
of
it.
a supernova too, if anybody has that. It says there's no true raw recording, like in real time, of a supernova from the initial moment because supernovas occur unpredictably at immense distances, making it difficult to capture. Okay, but do we have any videos of like the supernova happening?
I've heard of people
video.
talking about
I don't know if the astronomers actually takes videos.
Or like this like quasar event that we're using?
Quasar are continuously putting out energy. That's not just like one explosion. That it's an ongoing process.
I thought you said the radio waves from quasars can tell us distance.
No. That the distance to the quasar is based on other methods, and but for stars you can use a VLBI up to, I think it is up to 10,000 light years.
Yeah, but how do you know that?
Yeah, it's
parallax. Very extremely
Dude,
accurate
this
parallax.
is crazy, bro.
This is getting off the chart, like ridiculous.
Dude, you're not.
I'm still trying to understand this like concept.
You're so
VLBI has a
dodging this. I don't understand. You just keep going back and forth, and you're not making any fucking sense.
No, because there are different methods for different measurements for different distances.
What does that mean?
Yeah, that's just.
It means that some stars are so far away that we can't do parallax measurements to them.
But you're not understanding. We're asking you, how do you know how far away the stars are? You're presupposing that they're far away. What makes it about the light that makes them so far away? Like, there's got to be something that makes you all go, "Oh, that's 1,000 light years," as opposed, "No, that's 10,000 light years." Like, come the fuck on.
Well,
so
what you start with
Cepheid
is
variables.
power.
Yeah, parallax works for like close stars, right? It's trigonometry, right? So if the base is the distance between the edges of the orbit, you can
How
make
far away is the
some
closest star?
triangle.
How far away is the closest star?
Proxima Centauri is the closest. I don't know how close it is.
Okay, and how do you know that?
That one was done with parallax. That's still
Parallax.
within.
Oh
They've
my
been
God.
working on it for a
Circular
long.
reasoning.
It's like it's
They've
like
been working on it for a
refraction.
long time.
You guys just
It
say
sounds
one
like
word and
circular
like
reasoning
it's
to me.
supposed to
Right.
do this.
If you don't know what that word is, Google will help you.
What word?
It's 4.25 light years away.
Oh my God, you say
Okay,
parallax, and I'm
so
just
break
supposed to
down
go,
like.
oh, it must be that then. Like, come on,
Okay,
dude.
so is it the parallax of the radio waves again from like a supernova? Or am I wrong?
For Proxima Centauri, no.
I'm just okay.
For
So
supernovae, so when we look at so galaxies, for example, right? Well, let's not get into galaxies. So with Cepheid variables
Yeah,
and
that's
type
not
1a
going to go well
supernovae,
for you if you get into galaxies. Just saying.
sure. There's type 1a supernovae have a specific amount of energy when they explode, and we know what brightness that should be. So when you look at a supernova, we can measure how dim it is, and knowing how bright it should be, that gives us an approximation of its distance. A
And
rather
when was
good
the last
approximation.
time that a supernova was seen or whatever? When was the
No
last
idea.
time that happened?
I have to look it up.
No idea. So we just assuming again.
No,
No,
just have to look it up. I don't know the
supernova.
specific date.
Yeah,
Oh my
the
God.
the SN 9087A, which was observed in 1987, is a really good example. How we at least know that one is far away, because when it went
So
supernova,
1987 was the last time we saw a
no,
supernova.
when that happened, it created like a pressure wave, and then it created like a big nebula. And they measure how take light pulses starting in the center of this nebula, how long it took for the light to reach the outside of this nebula. Looks like a ball. So by timing the time the light took from the center to the outside of this, you can easily calculate the size of it. And at the same time, they did the angular measurement from Earth. So by doing that, you actually know the size of that nebula, and then you measure the
By what?
angular size
By what? How? How do you know the size?
by optic telescopes and
Optic
X-ray
telescope.
and infrared as well.
I
So
thought it
it's
was
Dude,
been
that's not a
parallax.
real
observed
answer though.
pardon?
That's not a real like
Parallax.
answer.
Yeah.
What? It was observed using telescopes.
You said
And
optical
it's been
something.
observed all the time since '87, and they see how this nebula and stuff is evolving over time.
Are you guys
So if you know
understanding
this,
how we think it's
but if
three
you
separate
know,
systems?
yeah, but if you know the size of an object, and you measure the angular size from your observation, you can calculate the distance to it.
But don't you need to know the actual size? Don't you need to know the size?
You just
Yeah, but I
said
just tell you how they know. I just said how they know it. It's the time light travels. They can see how light travels through this nebula from the center until they reach the outside of the nebula. So that's just speed
The whole thing is
times time.
glowing. Have you
It
seen
is
a
glowing.
nebula from a telescope?
Wait, don't you need to make
If I
assumptions about the media interaction of the medium?
That's all assumptions.
no,
Every
Yes,
bit
you
of
do.
it.
so
The propagation rate of light is relative to the medium.
okay, reduce it to half.
Dude, it's
Let's say
all
the speed of
glowing.
yeah,
Okay.
yeah,
Oh
it
my
is,
God.
yeah, because of the neutron star which is left in the center.
Oh my
No,
God.
I've looked at these
But
things under a telescope, like under like university telescopes and research-based telescopes. and like they can do like long like time lapses of these like portions in the sky to get these galaxies. I'm not sure by that how you would say like how light's traveling from the center to the outside though.
So even if you, let's say the speed of light was traveling at half the speed that it normally does, it would still leave it about what, let's see, about 85,000 light years away.
What?
What? You're not like making any
The
sense.
light from
You're
the
saying
inside to
stuff.
the outside is not going to tell you that it's supposedly 85,000 light years away. I checked out for a little
No, the
bit,
angular
and I
the
come back
angular
and just feel like the most
size.
ridiculous. What's up?
No, the angular size, the actual size of it is measured by looking at how long it takes from light traveling from the center to the outside of the nebula.
How are we watching
I
the
just tried
photons travel?
The angular
because it
size,
reflects
okay, so it could just be, it can just be
reflects.
smaller and closer.
You have light
what makes them
echoes
not-
coming off different densities in the nebula as it travels outwards. So you observe how the light reflects off different objects, and the further away from center, the longer it takes before that light is reflected, which means it's traveling outwards.
Have you seen any of these things under a telescope? Because
Wait,
the way
did
you're
you just
describing
ignore
it,
what I said?
Not personally.
It could just be smaller and closer if all you're getting is angular size.
Then light must travel at a completely different
No, why?
different speed.
Why? No. First of all, you're assuming a
Yes.
medium.
Not at all.
The light's going to be perceived relative to a medium. Secondly, if you're just getting like an angular size, it could be smaller and closer, factually.
No. If the light is traveling from the center to the outside, it's just like
Unbelievable.
driving a car speed from the center of the circle until reach the circle itself. So if you drove a car from the center of a circle and you drove 60 miles an hour for an hour in a straight line, you would know that the radius would be 60 miles. It's the same system. It's just that it's not a car, it's light.
the other.
So
Dude,
you're
like, you
looking
have to start
at
from these
nebula in the
basic
sky,
assumptions.
and you're claiming that you're seeing light traveling from the inside to the outside, but you're not actually seeing light traveling. For starters,
They did.
they
How
saw
do you
light
watch a
travel.
photon travel?
Let me post an image of this so it gives you a rough idea.
Please
It gives
post
you a
like
rough
raw
idea
images, dude.
what it looks like.
Have y'all seen my star videos from like observatories?
Yeah,
Have y'all seen any?
yeah, they're dope.
Yeah, I mean
I have not.
the amount of assumptions they do based on these things. I mean, even like exoplanets, like they don't really directly see them. They'll just see like a little twinkle in the star. There have been a couple exoplanets that they said that they've seen from ground-based telescopes, but it's like a tiny little pixel of light, and it's like I wouldn't even know the difference like from it and a star. But that's not the topic. I think that there's just a lot of assumptions being made with the distances, and there's like if you actually look at this stuff through a telescope, it's crazy how many assumptions they're making on all this stuff. Like, I'm trying to figure out right now, like how are they doing the size and the distance, and it just seems like it's based on circular reasoning with like these underlying principles that assume this whole model, but how would we be able to differentiate if we don't know which model is correct? It just
Well,
seems
Like,
Taylor,
don't you think it's weird? Don't you think it's weird how you guys just accept light years? Like, oh no, like earlier you were saying, oh, it's only 10,000 light years. Do you know how far that fucking is? Like, that's ridiculous.
well, wait, Taylor, I just want to say about there being assumptions made within the standard model of cosmology, right? I mean, that's normal. Every scientific theory, as I'm sure you know, has assumptions, right? There's some baseline assumptions. There's some gaps, right, that are yet to be tested, right? But unless you have a competing theory that makes less assumptions, right, and explains the same facts, if not more, what are you saying then? That we just
I
don't
just
know this
presented
part?
that. I just
it wrong.
Yeah,
presented
dude,
that
like
and
you
it
can
dunked
come
all over
from
their
like
model, and it's not even close. I don't need
Just
dark matter, don't need dark energy. It's way superior. And then they just breeze right past it and go back to another hyperspecific claim, pretending that absolute dismantling didn't happen.
I'm
And
sorry.
they
What
make
did you
some
do?
hyperspecific.
I missed that. I wasn't
I
here.
explained
In
a
fairness,
significantly more viable framework with the geocentric universe, a fluid medium. I explained that the entire universe could have superfluid. It wouldn't even be detected in spectroscopy because it doesn't have viscosity. It wouldn't create absorption and emission lines. And then we would have plasma inside of magnetic fields, giving us the speed of galaxy rotational speeds, etc. That could be immense even with weak magnetic fields. That the magnetic
Oh,
fields could
slow down,
explain the
Witsit.
galaxy. Well,
Please
I don't
slow
want to
down.
say it all too much. The long story short, a
Uh,
very quick summary is that you could have a much smaller, more dense local universe that's finite. Everything would be electric and magnetic within a fluid background, and there'd be a geocentric universe with the Earth in the center. And these galaxies, for example, would be magnetic in nature. And so what they're claiming is gravitational is actually magnetic. So we wouldn't need dark matter to fix the problems of missing mass because you could have any amount of mass and have just accompanying magnetic field strength. And we wouldn't need dark energy because the Earth being in the center means you don't have to say that the universe is accelerating and expanding, creating the illusion that the Earth is in the center. It looks like the Earth's in the center because it is. So now we don't need dark energy. So we don't need dark energy or dark matter with that model, which is over 96% of the composition of their universal model. And we can replicate this in a lab. When we take plasma with magnetic fields, we can perfectly replicate all the different types of galaxies. And it goes on and
and
on.
Witsit, please. With all
in
due
fairness, I
respect, my
didn't
guy.
breeze past it though. I did engage.
Yeah, but
And
you
also,
just
it's like
you just butchered it.
this is like so much at the same time. Witsit, man. Uh,
Well, you have to listen back to it,
yeah,
because it was like a
Yeah, I
lot.
you're
want
There
to
was a
throwing
lot of it.
and you throwing around words like I think like a bit like
It's repeatable,
irresponsibly there.
observable. We can
W-
do this stuff in a
I'm
lab.
sorry. We have. I'm pretty sure there's a lot of facts, right? Like if we compare it, like point by point, like facts that we know about the universe.
Well, yeah, I
Uh,
did this with Professor Parks, who was a PhD astronomer, right? And then a professor, and
I,
he was
cool.
yielding to it.
Well, oh, wait. Is that guy who said that you cannot like fuck? What did he say? I think we were like watching that debate between. We're like, why is he granting all of these things that we've been in fact proving to you flat earthers here for like years now,
Can you
right?
not change the
hang
topic?
on.
But sure. No, never mind. Never
Please
mind.
don't change the topic.
I was
Well,
just
no, wait,
addressing
no,
your point with
Tyler.
a metaphor. I
Well,
wasn't trying to re-describe everything we've talked about for the last 2 hours. I was just saying that we did present alternative, right? And like she's founded in saying, well, you have to make these base presuppositions, right? Because the whole like sizes and distances claims within their model, it's all a house of cards built upon presuppositions. And some of the leading people within that paradigm know this and
Witsit,
knew
please.
this.
Then let's keep on topic. Wait just a sec. So, okay, right.
That is the
But
topic.
the thing, right. But the thing is, right? I don't know. Maybe you are just a genius, like a prodigy.
Dude,
Astro. Hello. Wait, still talking.
Dude, can
Astrophysicist
you?
that actually. Hello, but I don't really fully understand what you said there, and I'm not gonna insult you right now and say that because it's like word salad just made a fucking shit up, right? I
Well,
would
everyone
ask
else
you to.
understood it though. So, I
Really?
mean,
Everybody? Yeah, really? Show of hands.
yes.
And repeat it, please.
Yeah, I mean, just the fact that we can actually do some of these things in the laboratory, like I was mentioning earlier with the star in a jar, which I wanted to make some follow-up statements on. Like, yeah, but
A
like
what? A
you have to
star in a
make,
jar?
yeah, have you ever heard of that?
Well,
It's
no.
plasma that you can actually create from sonoluminescence in a laboratory. They use it to study stars. Anyway,
Okay, and
just
what is the conclusion of
repeatable
that
things.
experiment?
Huh?
What's the conclusion of that experiment?
I think it explains stars better than this, mainstream theory. And the assumptions for the parallax, by the way,
How
is
so?
the diameter. Hold on, is diameter of Earth's orbit. So I just want to say a follow up based on the last conversation, since we're kind of moving on very rapidly.
Yeah, it reifies the orbit. Yeah.
Like, can you post that experiment?
It depends on which method they use with the VBLI.
Yep.
Yeah, because they either reify the orbit, they reify, of course, like if they use a baseline on the Earth, they're reifying the geometry of the Earth, of course. Then using that distance, it reifies isotropic assumption of light. It reifies the constant speed of light within a vacuum that's assumed, and the list goes on and on. And then you have to take those assumptions to build, say, the size claim, and then you assume the distance built upon the size claim. So it all builds off the base presuppositions. This is why I said you're even to say from the inter portions of the nebula to the outer portions, you're having to assume the medium and the rate of speed or the rate of light propagation.
I'm sorry. And
And
how
that's
many
just
things are
fact.
you assuming?
What was
Oh,
I
that's a
We're
great
assuming
calling
about
out
question.
that?
their
How many?
assumptions.
How many assumptions does your hypothesis have?
No, I'm the one that says,
Right?
hey, this is limited intrinsically to speculation. And I can just point out that we have a way more viable framework. We don't need dark matter and magical dark energy to make ours work. And we can actually replicate ours in a lab. She can show stars in a lab. I can show galaxies in a lab. We can show all the phenomena in a lab, the celestial motion in a lab. They can't show
You
anything.
didn't answer my question, though, did you?
Any
No,
claim
he
about the
totally did.
sky intrinsically requires assumptions because you can't physically
I
go
asked you
there.
how many. You're the creator
Many
of this theory, right? This is your theory.
what a goofy question. I'm all right. I'm disengaging, bro.
Really?
You're asking
It's
for
a
a number
wait.
of
Yeah, you're kind of like
assumptions.
throwing the
It's the
conversation
I'll,
off.
goofiest question you could
yeah,
imagine.
just like an approximate right comparison between the standard model and the Euro model, right? And that is literally the topic
Pi
of
makes
this,
way
right?
less
The point.
assumptions. Pi makes
Cool,
way
right?
less
You see,
assumptions.
well, how much roughly, at least
Dude,
compared
you
to the
Like
came
Euro?
in and
roughly
said, I want a
85%
simpler
less.
model. You said you wanted a simpler model. He gives it to
Well,
you.
that's usually no. That's what I'm questioning, sir. I don't know if you paid attention,
How
but I
much have
No,
guess
you
you
I'm
do.
good. Let me
researched?
give you one
I guess
quick
you don't know.
example of
Sure,
how it's
never mind.
simpler and
Sure,
see if you
never
can
mind.
be intellectually honest about it. Okay, Edwin Hubble got these giant telescopes. We looked out into space and we saw that all the observations showed the Earth in the center of the universe. Option A is it looks like we're in the center of the universe because we're in the center of the universe. Option B is it's an illusion. We're not actually in the center of the universe. Everywhere looks like it's in the center of the universe because it's accelerating and expanding in all directions faster than the speed of light. And it has some magical energy force that's causing it to accelerate and expand called dark energy that we can't define and can't find and have no idea what it is. Which one of those has less assumptions?
See, that's not how we evaluate, right? Okay, and how many facts, right, does your theory explain compared to like that one that you mentioned? Just that we're not the center of the universe, and in fact, we're like orbiting the sun, and the moon is orbiting us, right? Which explains, by the way, if I'm not mistaken, I mean, correct me if I'm wrong, like motions of like retrograde motions of some planets, right? No other
Hmm.
All
model
that's
explains
equally
this.
explained within a geocentric universe because
How?
there's a
Without
there's a ki-
gravity? Without
because
orbits?
there's a
Okay.
kinematic equivalence. Okay,
Hmm?
meaning this is what relativity requires. Meaning everything we see moving in the sky, you can claim that we see a lot of it because we're moving, or we see a lot of it because the stuff is moving. It actually requires more assumptions to assume we see it because we're moving, and that's kinematics. So when you bring up retrograde, it has nothing to do with gravity. Now, if you want to bring up what's causing them to move, they claim gravity. It doesn't work. They claim that 90% of our solar system has to be, of the matter in our solar system has to be dark matter or our galaxy or whatever. They claim that
Or
their
yeah.
gravitational model doesn't work.
So how
So
does
it's like,
so wait, so how does your so wait, I think you're kind of dodging this, right? So
What?
again, I'm pointing out to you that your hypothesis, even though it makes fewer assumptions, right on the face of it, actually is not sufficient because it doesn't account for as many facts as does the competing
No, it has
hypothesis. What is standard?
reproducibility.
No, no, it does. No, it doesn't. How do you
Yes,
explain?
you don't.
How do you
Everything that
explain?
you
No,
have
wait.
is like
Well,
an
wait, wait.
AI
Actually, sorry.
model.
Wait.
You're just
You're
like
simply
railroading the whole
you're. Si-
conversation.
what are you fuck talking about? I let
Yeah,
Witsit
you
talk. I'm
coming in and
talking.
you're bulldozing. Nobody else can even jump in. You're
No.
just like,
What are you talking about? I let Witsit talk. I let you talk.
me? When'd you let me talk? Like, I just tried to say something. And it's just like, Yeah, I'm
Well, I
trying to
was
answer
You're
your
talking
taking us all the way
actually.
back to like square one in a
I
super
was
I'm trying to
actually
rudimentary.
talking and responding to Witsit, then you interrupted me and then said you talk
Yeah,
now.
do you
I
get
know,
you
but
get
I'm just trying
her
to like
problem is that we were having like a super hyper specific conversation that's been building for like an hour and a half with specific observations, and you come
Yeah,
in and
sure.
brought us all. Don't interrupt me, please. You're bringing us all the way back to step one with a super meta, vague, elementary assessment.
Stop doing the
Largely,
meta
that's
now. Sure.
yeah,
already been
please.
explained.
I will let it go. Sure. I was just challenging like the base assumption that Taylor had there. Okay,
Well,
now
it's
go
all
ahead.
Okay,
good,
can I
but
go back
my
to
model's
solar
superior.
specific?
So
So I was gonna go back to the star in a jar earlier, okay? Because we're talking about like reproducibility. Can we actually like see some of these things or reproduce them in a lab? You know, obviously we can't reproduce like the star in the mainstream model in a lab. We can do sonoluminescence though. It's very interesting. And I think what's his name, Stefan, he was like positing like kind of like a rebuttal to this in the sense of, oh, well, they have like X-rays or whatever. X-rays, essentially all of the X-rays are blocked by the atmosphere. We're talking about like from, you know, comparing stars to like sonoluminescence. Like, okay, so with stars, like the Earth's atmosphere will basically absorb all the UV radiation through like oxygen and ozone, okay? And X-rays, same thing for ultraviolet, mostly completely absorbed by the atmosphere, and then also most of the infrared. Now, what we do get from the stars is visible light, obviously, some radio waves, especially with, you know, some high powered events or whatever. It's like not every star we can get radio waves from, but they'll say like the more powerful ones or whatever we can get some radio waves from. Let's see. Yeah, and then the infrared, some infrared, reaches the Earth. And it's funny they say like through like these quote unquote atmospheric windows, where water vapor and other atmospheric gases allow partial transmission. Okay, so so they have to like use these on like high up mountains and stuff to get IR. So essentially, the ones that we can receive from stars is radio waves, infrared, and visible light. Now, I was trying to compare this to the sonoluminescence because earlier, you know, like Spawn was saying about the spectrographs or whatever being different. Now from the sonoluminescence, it's actually interesting because they can reach 20,000 to 70,000 Kelvin, which is comparable to the temperature of stars. And they say in these sonoluminescence, like quote unquote star in jars, they actually have plasma that's being created. Like this is like literal plasma, and we can use it to study plasma because of the energy and intensity and heat that's like produced by the collapse of the bubble. And so they actually, yeah, visible light and infrared is produced by them. Now, in terms of radio waves, I could not find if they particularly tested if they emit radio waves or not. But based on the amount of energy that they are giving off, like it'd be reasonable to conclude that they do. But so from my, you know, studies, like looking into this stuff, I posted some papers on it in the past, and I can send you those as well, to the guy who was just talking. And yeah, they seem very comparable to stars. They use them to study them, and fundamentally, it seems like they're giving off the same output from what we can observe from stars on the ground.
Well, what about high altitude balloons
Wait, what?
measuring the electromagnetic spectrum from stars? What do they tell us? I suppose you don't agree satellites exist, so let's go by really high altitude balloons.
I'm not sure what you're referencing. What do you say that they are getting that we're not?
How much of the electromagnetic spectrum does those measurements do the atmosphere block in those measurements?
I am not sure. All I know is like we can receive visible light, radio waves, and some IR from stars on the ground.
At the ground, yes, but the high altitude balloons, you get
I
more or
don't know.
less
I thought you were
everything
the
from
one
them.
that posited the model, like that there's a different spectrograph from like the sonoluminescence. So I would think that you might know that.
Yeah, well, from my understanding, it's UV visible and infrared, which comes from luminescence. But from stars, you have the whole spectrum, from radio waves all the way up to X-rays
You think we
and
get gamma
everything
rays
in
from
between,
stars?
and everything in, like measured by high altitude balloons.
Okay.
But
Yeah,
it's
you
not
can
the
send me
same. It's
that.
not
Like
the
send me
same.
whatever you got, bro. I'm
Yeah.
looking into it. I'm willing to
Yeah.
look at any
So
paper, any study, you know, whatever.
Amen.
If they have some, like, even from these like satellite based, you know, observations, like I've looked into some of those. I think they have a lot more speculations and assumptions, and less like it's less clear than people like project that they are. But if you have that they are like we're receiving some like rays that we're not getting from luminescence, like I would totally be check it out, send it to me.
Yeah, there's something else interesting in regards to taking astrophotography type of pictures and videos, which I've done quite a bit. So if I aim out of off my front porch or my parents' porch or my girlfriend's porch, whatever, I can see certain stars, zoom in on them with a camera, and then it looks kind of the same. But then another camera, another star, same camera, same night, zoom in on it, and most of the stars don't do that bright type of flickering and dancing motion. And I've heard some people say that it is basically just because the camera wasn't focused.
Wait,
turbulence.
stars don't do flickering?
You know, when stars are flickering, that's mainly turbulence in the atmosphere.
Okay, well,
Yeah,
some
it can
stars do it.
depend on where it's at on the horizon. But if you do like a long, like a time lapse, which that's what many people post videos of, like the time lapse, like it won't flicker. And also, like if you can also see the flickering better if you like record if it's focused really good and you record it through like the eyepiece or whatever, or even like take a video straight from the telescope, like to down, like instead of it going through the eyepiece, it going straight to your phone, kind of like you could do with a microscope. Um, take like a long, like take a video of that and then just zoom in on the star. You might be able to get that, but not every star is as not every star you know has like the beauty of like the twinkling ones like Sirius A star. So yeah, some of them especially that are more faint might not have that very pretty effect.
Yeah,
They cause scintillation.
most stars I've looked at, as you were just saying, Taylor, not all of them have that. What
Mhm.
most of them, if you zoom in on them with a P900, P1000, or whatever else, and even adjust the settings on it, which is fairly simple, and you zoom in, and some of them will do the exact same thing from
Yeah.
different locations. But then you look at some of them that are definitely, it looks like they're made out of a bunch of donuts or something. You know, just these rings. But most
Okay. I don't know about that because it depends on the focal point of the star. So I'm gonna share my screen. I'm logging into Twitter on my laptop right now. I'm gonna share my screen. I actually got the astronomer to like focus on the stars at different focal points, and you can kind of see that donut effect occur.
You got
One
him? How
second,
did
I'm
you
logging
get
in.
him to do that? F2I.
Yeah, because I've been
Oh,
to
yes. Yeah.
I mean at my university, they
No,
have
I
like
was. Oh, never mind.
what?
Ignore my comments. Sorry.
You said how did I get them to do that? I thought that's what you said.
No.
What are you talking about?
No,
I didn't hear you
I
then.
do that with my
No,
telescope
just
as
ignore
well.
what he
It's
said and no, it was way out of pocket.
What
if
happened?
your
What did you
output
say?
It just
if
implied that you did something to get them to let you use it.
I was a
yeah,
little
What?
why
joked
not?
over by Dojos. They just ignore
Are
it.
you kidding me? I'm like in a
I
public setting
wasn't
with other people
joking.
there. Like, what are
Oh
you
god.
talking about?
Bad joke. Go ahead. Continue.
No, I have like I have a friends who work in like the astronomy department, and yeah, I went to actually a couple of the videos I posted are from different observatories as well. Um, let me go ahead and share my screen. One second, I'm trying to pull up these videos. I want to show you guys because this is like this. I'm literally like looking at what they look at to make these assumptions. One second.
Yeah, and as you're doing that, the parallax, according to the actual definition, is basically just a zenith angle type of a. Or is Taylor ready? Is she?
No, go ahead. Yeah, I'm just pulling up my thread.
Oh, okay. So if that particular type of mathematical angling type of a formula is used, then every single star in the sky is approximately the same size and same distance away. And that same thing can also be used with the moon and the sun. And the transit on Venus bullshit. I'm not buying that.
Yeah, let's do a parallax of the moon.
Okay, we can do the same thing with the sun then, right?
It's harder
Oh,
with the
video
sun
isn't available
you got
because
no background.
there's more than 25 people in here, so I can't show it. That freaking sucks. How do we upgrade this? Yeah, I can't share my screen. It says I can't share it because there's more than 25 users.
Drop it into the main chat. Maybe someone else can.
Normally you can share your
That's
screen, just not
lame
your
though.
camera. You can share your screen, just not your camera, right?
Yeah, I thought so. Yeah,
Mm,
I've never heard of that
I
before.
wasn't trying to do that.
Yeah,
I can,
wanna
yeah,
parallax
I
the moon,
can share
Andrew?
though.
Me and you'll parallax the
So
moon.
stupid.
There should be no limit on sharing your screen, just your camera.
But why?
Oh yeah, I don't know. You just got to set up where you can't share your camera because what happens if there's that many people in here and you share your camera, everything lags out super hard.
It's just a Discord limitation. It's just all
Okay.
of Discord. Yeah, all of Discord. Like you can't even upgrade it
Dang.
with Nitro or anything.
Oh,
It's just
what was I
across the
thinking?
board.
That sucks.
Okay.
You can do it in a
Okay, let
stage
me.
channel. You can do it in the stage channel, but just not in a regular one.
Nah, hold on. I'm trying to like turn off my notifications. I've got some like really like
Just go to do not
personal
disturb.
notifications.
I
Oh,
think there
shit.
might be a loophole to it. Like if this is being streamed to what, YouTube and Rumble at the same time.
What? Just if you do not disturb, then it won't even show your notification.
How do you do that?
Scroll.
I've
If you have an
never turned
iPhone,
that
just
on
pull down
myself.
from the top
Uh-huh.
and then go to the focus area and click on it, and then there's a do not disturb option.
Okay. I don't see that. Yeah, hold on. I'll do it on my settings.
Pull
I
down
don't
from
think
the
I have that.
top, and you're gonna pull down from the top where you see Wi-Fi and Bluetooth and airplane mode and stuff.
Okay. I
And
found it
then
on
look
here.
below that, you'll see focus. Yeah, click on it and then do not disturb.
Yeah, I just counted. There's 15. About half, a little over half of the people here are actually using cell phones.
Yeah, I like almost only use a cell phone on Discord. Super convenient.
Yeah, it's just I love cell phones. I just hate how people actually use them.
Well, Discord finally upgraded where you can share your screen on an iPhone, so I'm happy. Yeah, we're good.
I thought that was always. Didn't know that. All right, what's
Okay,
happening?
I got it on. Okay, so let me share my screen now. Sorry. Okay, can y'all see?
Now, one moment.
Yep.
Can y'all see my screen?
Yeah, you're on X.
Yes, ma'am.
Okay, so here's the star in a jar, by the way. I just want to show this link while I'm here. And here's like some of the spectrographs from it. And you can do it. They do it in water, and there's a couple other mediums they can do it in, but it doesn't happen. So look at this star, like kind of what it looks like. I think I have a video too. Just it's kind of cool to compare it. Here, let's watch this really quick.
Transfixed to look at this spherical flask of fluid, and you look into the center, And in the center, see a glowing blue-purple light, which could be seen with the unaided eye. It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star. The process
Okay.
called sono
All right.
lumin-
Now let me show my. Have to go down to find my star videos. 1 second. I think if I go to media, I'm not. Yeah, 1 second. Oh, here we go. Perfect. Okay, so these are done in different locations. Let's see. Here's one of them.
Back in when I was in the UK, back when we got awarded time on a telescope, actually.
And it can. This is actually a dual star. Like this is 2 stars next to each other, and you can kind of see what it looks like under a telescope.
Go Tokyo University. This is how much this is worth. And sometimes I kind of wish they did because no. I don't
Okay.
do those. Back in when I was in the UK.
This guy is just talking about when he was awarded time on telescope in the UK. All right. And here's another one.
Think a planet the size of the size and massive. This is like Jupiter size.
It does look like it's underwater, and they acknowledge this. It's called like scintillation. They say it's from the atmosphere or whatever, but
You take out
just
the K in that, please.
What'd you say?
The C is silent in scintillation.
Scintillation? Okay.
Basically, they're big.
All right. And then let me scroll down. This is one of my favorites, Capella. It's really beautiful. And like when I uploaded them to Twitter, they lost some of the quality, but you can still see like the general effect.
And you should drop them in
and
Telegram.
that's cool. Oh, here is the one at different focal points. I got them to basically focus at a different points. And I have videos too, like where they're like focusing in and out. This is just like a shortened version. This is on like a telescope that you can buy, like a Celestron Nexstar 8-inch. So if you were to buy a telescope, your stars would probably look something like this. And I've tried to look at them under a P900. I've had a little trouble doing that though. I need to like work on a little bit more. Here's a SkyQuest, a star under SkyQuest, which is another telescope you could buy. And then this was another video of one of the ones I posted. And then here's Sirius. All right, here's another one.
You need to have a much larger star in order to do that.
So yeah, I mean, see how they scintillate a lot? So to make any like assumptions on parallax based on this is, you can see why that might be like an issue because they're already kind of moving around a lot.
That's why we use space telescopes for parallax.
Okay. Do you have a raw video? Do you have a raw video of a star from a space telescope? Because I've tried to find them, but I can't.
I don't think they really take videos.
Yeah, they take photos.
Oh,
But
no.
there are actually stars that are enough close that you can take parallax from Earth, and and that parallax will be inside of like the margin of error of a casual telescope, like the Barnard star, for instance. You can measure a parallax of it without any problem. As a natural
Barnard star is really about proper motion, not so
No, it's
much
both.
parallax.
It's both.
Yeah.
No, I am also aware of its proper motion. It has the fastest one of all stars in general, but it also has parallax.
Yeah.
Because it's very close. Like, it's a red dwarf. Is it a red dwarf?
I have no idea.
I think it is. if a star is a red dwarf and you can see it in the sky, then it has to automatically be pretty close because they are very dark. So if you can see them at like any significant brightness, it has to be close for like this close distance to compensate for the fact that they are naturally very dark.
Okay,
Okay,
so
Taylor,
could
the
we?
answer is no, they don't have videos of stars in space. They'll never show them to you because it's all fake and gay. Because if you got out away from the Earth, it'd be super hard to fake those stars because you'd have to adjust for their position. So the actual angle on which you observe the stars would change. And it'd be a super difficult thing to fake, right? So that's why they don't ever show it to you on any of the supposed space missions. They never will because they'd have to update the position of the stars relative to their position. So if they're claiming to send a satellite way out into space, they're not going to show you like a video of the stars, unless they're really confident in AI now. I don't know, but
Yeah, they're probably working on that, and they'll probably go back into previous. What do they call those?
We've had plate
Ah, go
solvers
back.
long before AI.
videos of
back.
stars out away from Earth where you wouldn't get the same angle of view from the Earth.
No, I said we've had plate solvers for a very, very long time, way before AI.
Plate solvers? I don't know what is that.
Plate
Yeah,
solvers.
I have no
So
idea what
you
that is.
give it a photo of the sky and it will identify all the stars. And from that, you can work out the parallax from a previous photo 6 months ago.
So from
No,
two
what I'm
angles.
talking about is like it would be super difficult to fake a video of stars from space. I get you guys think it's real
Right.
or whatever. Let's say hypothetically they're not really sending satellites far out into space and they got all their excuses for why I don't give you videos, whatever. It'd be super hard to fake that video because you would be seeing the stars from a different position, a different angle. And so we'd be able to fact check it. We'd be able to say this is supposed to be here, and here are the stars that should see from that angle. And if they mess up on one little thing, right, it's over.
Yeah, but you're not
What
going to
would
have
be the point of
like
taking the
Taylor's talking
video
about
then?
scintillation, right? We're not going to be able to measure the
No.
parallax to milliarc seconds from inside the atmosphere.
Sure. I was just making a separate point, right? Which is like you're not gonna ever get a video of stars from space. So
But what would be a point of doing that? Like you're taking something that you
what?
wouldn't even rationally expect to be taken, and then you're making up some stories
What?
about it.
If
What's
we
the
get
real
out
reason?
away from the Earth's atmosphere where you're in a sea of stars, the most beautiful thing imaginable to man, you wouldn't take a video of it? That's your
They
argument?
take photos.
Yeah,
These
A video
telescopes
would
take
be
photos,
way
not videos.
dude, a
you
video would
can
be
take
amazing, bro. Especially if an astronaut's floating out there, they take a GoPro and they do a 360. They show you swimming in stars. It'd be the most incredible thing ever.
you can take a
These aren't
video
manned.
of stars from the Earth, of the same exact stars.
Again, you would do a 360 swimming in stars.
These aren't manned missions. Gaia and Hipparchos, they're just fucking
No, I know.
telescopes.
I brought up the idea of an astronaut who will never do it because they don't go there. And even the ones that aren't manned, right? You should be able to take videos and do a whole different 360 angle that you can't see from Earth.
Why? Why would you take a video? They just take photos.
This guy just claimed he wouldn't because you can see him from Earth. He's wrong, obviously, because you can't see 360 in all directions on Earth. I mean, I guess conveniently for you guys, you can say, "Oh, why we don't need a video? We have a picture." And I'm saying, well, that's convenient because they can't fake a video because we would catch them lying and faking it. So
How would you do that?
Or maybe
I can't imagine
like
how you would do that.
because if they're going to claim that they're out in space, their observational position is going to be different. So it's going to have to
By how much?
It doesn't matter how much. It's just that it would be
Yes,
different.
it
So
does.
the start. No, for example, Polaris is going to be in one place for you on Earth. If you go out into space over to the left a little bit, it's going to be a different position for you. And then you're going to do a 360. All the stars are going to be in a different position all
By
around you.
far less than an arc second. Far, far less than an arc second, which you're not going to be able to resolve from the ground with your shitty telescope.
Dude, we've given them billions of dollars. They can't take a freaking video of the stars up there. Are you kidding me?
Not one exists ever.
That's so stupid.
There's plenty of them. There's plenty of them from the ISS. That's
Yeah,
just the
the ISS doesn't
ISS.
count. We've already caught them faking it. The stars go
No.
into
No,
the
no, you
horizon.
haven't.
The stars go into the earth.
Yeah, I mean they do. That's the point of the bottom-up abstraction that they go
No,
below
the
the Earth.
stars are seen. My guy, in some of the ISS footage, the stars are seen through the Earth. Like when they're supposed to be going down behind the Earth, the layer of stars that they overlaid is seen up through the Earth.
I bet
Okay,
you're
Can you post
confusing
that?
the I bet you're
I'm just
confusing
looking.
the Earth with
Hold
the
on for a second.
atmosphere around the Earth.
No,
I
it
bet
goes
this
way
is the
into
case.
the Earth. We all sat here, even with Glovers, desperately trying to explain it away.
Then post it.
No,
I
you can
bet
look it up yourself.
this is what is happening.
I remember effortlessly finding it when I went to relook for it. It's like a large percentage of the ISS footage that where they show the time lapse of stars and stuff like that. If you just go frame by frame by frame, you start to see stars go down into the earth.
I'm almost certainly sure it's going to be the atmosphere because the atmosphere it kind of glows during the night
No, I know what
from
you're
looking
saying. I
from
know
the
what you're
outside
saying.
because of all of the streetlights and stuff like that. So you can confuse the
No, the
atmosphere
Globers
with the
made
Earth.
way gayer explanations. They talked about dead pixels and all kinds of nonsense.
I mean, if you have a random white pixel happening for like a frame or two,
No, it
then
was
it could be a dead
it
pixel.
was the star continuing on through the earth. And no, it wasn't just the glowing layer around the earth. It went all the way into land masses.
Then show it.
Look it
Just show
up.
the video.
I'm like
I don't have
half
I am not
asleep.
sure.
I don't care if you
Bro,
believe me. Dude, think think about how much I care if you believe it. Literally none at all. Like literally not at all. So I don't have to run grab it for you. I don't care if you believe it, bro. Like I literally don't care. I mean, someone that's
but you
actually
know what I'm
curious, they can
saying.
go look into it. Someone that desperately wants to hold on to their fairy tale that we go out into vacuums, then don't look into it.
But you know what I'm saying. I don't have any business to try to find evidence for your claims that you have to defend.
I don't care. Like I didn't tell you to find anything. You're the one asking me to go get it for you.
So we
I'm
can
pretty
just
sure
You don't
Gio
have
was
to
in
believe
here.
it.
We pulled them up, shared the screen, and went through the videos frame by frame.
So we can just all admit that your claim is completely baseless and we can move on because we have nothing to discuss
He
about.
wasn't
Like I'm
using that
going.
as like
And then we can all agree that literally no one cares at all if you believe it or not. Like literally no one in this entire room cares at all.
I care.
Okay, Ruif
I
cares if
also
you
care.
believe it, so you guys can go talk in DMs about how you don't believe it.
Can I slide into DMs, Hembo?
You want to DM me?
No, don't worry.
Why would Artemis not show us videos of stars? Like, why just like videos in general as it goes to the moon, right? Like, bro, like, why do we give them that much money? We can't even get videos, dude.
You should sue them.
No, it's like you guys say there's no reason. Yeah, there is. It's the first return to the moon. You should take videos of it. And you guys got basically no pictures or videos when they claimed to land on the moon, and then it accidentally tipped over and we can't show you anything. And you guys just took it on the chin.
Never once did
Because
they
when
ever
you go
spin
to the moon, the
around and
first
show the
thing you
Earth
think
from the
about is
moon.
the stars. The stars is the first thing when you go to the moon. That's the first thing you think about.
On the
The
way to the
stars.
moon, you would just make the video of approaching the moon.
Yeah, and
My
they
guy.
did so, and they exposed the
They
video
did not do
for the
that.
moon. They did.
They did not. They gave us pictures that were trash.
No, there is literally a video of them approaching the moon, of them orbiting it. Bro, you're just lying
Orbiting
at this
what?
point.
I don't remember
You're full
that.
of
Maybe
shit.
they did.
Can't share my screen, but I think
I
I found the
remember
star
still
video.
shots that people put together to show it. So
There's,
feel
I
free to
think,
drop
there is.
the continuous video should be in high definition of us supposedly approaching and orbiting the moon.
That's what a video is. A video is this series of frames stitched
Oh, look at
together.
that. Look at that. So it's
That's
not a
so
video.
fake, dude.
Yeah.
Dude, looking at these like ISS videos looks so fake.
Dude, the
These look
Artemis mission's
so
even
fake.
worse. I can't believe any dude, what happened after the Artemis returned their pictures, most Globers didn't even mention it. Like instead of like having the big celebration day of Globers on Discord, none of them brought it up. We had to keep bringing it up, and then none of them wanted to defend it, and most of them admitted that it looked terrible and that they were very disappointed. So, but Imbo was super satisfied and thinks they did a great job.
Yes, I think
Well,
they did a
One of
great job.
are you even
one of
in
the big
America? Did you even fund that trip?
No, I'm not in America.
Okay, well then you don't even have the right to complain about it. So we're the
Dude,
taxpayers. We
this
said it
looks
sucks.
so fake. I'm gonna post some of these. This is so funny.
Get tens of millions of dollars a day. You can't give us like pictures that are better than Nintendo. It's just a joke.
dude, and all you had to do is spin the camera around from the moon and show the Earth. Like, what the
Why would an
failed? You guys
astronaut never
failed.
have done that, bro? Like imagine
Yeah,
being an
not once.
astronaut going out on a spacewalk. There's Earth behind you. You're out in space. You're swimming in stars. You can't bring a GoPro out there with you and just do a 360. Never
Yeah, and then
happened.
Neil Armstrong comes back and says you can't see the stars because of I don't know what his excuse was, but
Dude, I talked to
Dude.
astronauts in person, face to face, asked them, can you see stars when you're on the side of the Earth, that the sun is on? And I got directly opposite answers from more than one astronaut. So they were supposedly all on the same ISS, doing the same thing, looking at the same stars. One told me you can see the stars, and the other one told me you can't see the stars. And then there's the official answer from NASA, which is that you can't see the stars. But then another one of the astronauts claimed that they did see the stars.
Okay, Imbo, I'm gonna tag you. Let me know if you think this looks real.
Yes, I think this looks real. Already watched the video.
You
Well,
haven't even seen it yet. That's just like
I have.
dogmatism.
No, I have seen it. I was watching it while you were talking. Like,
And though, are you not even like phased at all by the fact that that some astronauts told me that they can see the stars on the same side as the sun, and then some told me they can't.
I don't think you ever talked to an astronaut. I don't think any astronaut
What?
would want to talk.
I've already
talk to
shown the
an astronaut.
video. They're readily available at NASA's freaking whatever it's called in
Yeah, it's in
Florida.
a documentary.
I had an annual membership. I went and talked
yeah,
to
didn't you get a
astronauts
pass?
multiple times. Yeah, I even talked to the astronaut that supposedly dropped her backpack in space.
Yeah, the
This
And
is
I
ISS.
a,
wore glasses and recorded it.
those
Yeah,
are
I'm pretty
very
sure if I
nice
was in
video.
space, I would be really surprised if everybody else had a different, you know, witnessed different stuff than I did. Like that's crazy. They all should have the same story.
Yeah, it makes no sense at all. They'll make excuses for it though. They'll be like, they were probably just misunderstanding, or they probably just misspoke, even though you asked them to clarify 3 consecutive times.
Where are the stars going to the Earth through the Earth, as Witsit claimed?
Wait, no, address what I just said,
Doesn't
bro.
really.
Like, do they see stars when they're on the ISS on the same side as the sun? Would you see the stars in
I
space?
have no idea what was the context of the question, how the question was
I
framed.
just
Doesn't
asked the
matter.
question. I just asked the question. When you're on the ISS, do you see stars in space when you're on the side of the Earth that the sun is on?
Looking towards the sun or away from the sun? If, let's say, the ISS is oriented in such a way that your window, the window they're looking through, are away from the sun.
Yeah.
Either way.
Did you ask that specific question?
Yeah,
Either way.
I asked either
Okay.
direction.
And what?
Asked
Yeah. And what
in
did
any
they say then?
direction. No.
In
But
any
one of them said
direction, yeah.
yes. One of them said yes, one of them said no. And then the official answer from Neil deGrasse Tyson was no.
Well, and there's a video
Well,
of other astronauts contradicting themselves, saying that they could, oh yeah, you can see stars, and then others saying no, you can't see any.
Because Neil deGrasse Tyson messed up and he said no because the sun is so bright that you wouldn't be able to see the stars. What he didn't realize is that the reason you can't see the stars when the sun is out is because of the atmosphere. So it's not just because of the sun. If there's no atmosphere, you'd still be able to see the stars. You can't
No,
see the
you
stars
wouldn't.
because of the atmosphere. Okay, so Imbo, you agree that all the other astronauts that said you could see them are retarded and liars. Awesome.
Well, you could see them if you didn't have the sun in your field of view. So like
Yeah,
the
hello.
ISS, it doesn't have a 360. It only has a view through a window. So if you don't have the sun looking through that window, then you're probably going to see them. But if you have the sun, then it's going to like block them because of its brightness.
So
Remember
its
they asked
brightness,
each other
just
like,
no
"Wait, could
medium
we see stars?"
because of its brightness in a
No,
vacuum.
Collins goes, no, I don't remember seeing any. And then Neil Armstrong's face, like for a split second, he's like, dude, shut the, like he's really watching him. It's a funny ass fucking clip to watch.
How come when
You
I
can
shoot a
totally
laser
tell
through
they're
a
being
vacuum, I
deceptive.
can't see it, but the sun in the vacuum is going to be so bright I can't see stars?
Because the sun shoots the photons in all directions, and the laser only shoots photons in one direction.
So if I put a
Really,
light bulb in a vacuum, I'll see it just like if it wasn't in a vacuum,
yes,
and it'll be just as bright.
yes.
No,
Or
that's wrong. The light interacts with the medium, my guy.
what?
The light interacts
Bro,
with the medium. And by the way, this is the official. This is what's so funny is Imbo's confidence right now will totally go 180 if someone plays the clip from Neil deGrasse Tyson explaining it, explaining why it's the atmosphere
oh,
that causes us not to be able to see the stars.
he's already been wrong in the past about many things, so I don't really care.
Okay, and then if we showed you the clip of the astronauts directly contradicting themselves, you would just make excuses for them, and then you wouldn't know which one to say. Would I
Dude,
see
I
stars if I
posted
looked if I looked away from the sun, but I was on the side of the earth that the sun was on, but I didn't look directly in the direction of the sun? Would I see stars in space?
I posted actual footage from the moon, right? The sun is not on the background and you can't see stars.
You said an
This is all
actual
just a
picture
question of
from the moon.
exposure, right?
No,
Wait, did you
video.
just
Actual video. No, video from the moon. I'll post it again.
an actual
I
video
actually
from the
do
moon?
agree with
Okay.
deGrasse Tyson
Yeah,
because
Apollo 17 liftoff from the moon. This is a legitimate video from their
Yeah,
archive.
that's
in
That's
yeah,
the
that
that's
funniest
video,
crazy.
fake video. Like the
in that
confetti
Uh.
vi-
coming out the bottom.
Why didn't they ever spin the camera around while they were on the
never mind.
moon? Would you go on the moon and then not turn around and show the picture of the how beautiful the Earth must have looked from there? And not one time
who's
out of all
who's
the times
panning
they
the
went out
Looking at
there,
the
camera?
not
size of the
one
Earth
time
from the
did they
moon,
ever
champ.
turn the camera. Did they ever turn the camera and show a video of it? They showed video of them hitting golf balls. Like that must have been really important, but no, like, you can't spin that camera around and show everybody, hey,
That is
look, we're actually
super
on the moon.
goofy. I feel bad for like the people in here that have to like make excuses for all of it too. It's like they're attorneys or something.
Like, dude, what is your job as an astronaut? Like, you just skip that one? Like,
You
maybe
wouldn't even be
show
able
a
to stop
video?
looking at the Earth. It would be like the
Yeah,
most incredible
that's
thing
all
ever.
that's all you would do. It'd be that beautiful. Not one time did anybody say to each other and go, oh yeah, there, look at the Earth. It looks great. Like they never say that. Out of all the hours of tape.
Because
Not
they're in a
once did
studio.
one say to the other and say, oh, look at the Earth, it's beautiful. Not one time.
Yes, they
Dude, did
That's
did
you
say
guys
it
know
crazy.
actually.
I found declassified documents that they had something called a rolling map method back then, which effectively is like green screen. But the declassified document was about the super sophisticated infrared rolling map method, meaning they were able to basically use green screen, but simply by separating the wavelengths of light using infrared. So it's like a super sophisticated form of green screen technology using infrared. And they classified this and our CIA was like obsessively researching it in the 50s, and we went and found the technology in Russia, and then they classified it. They classified freaking like movie technology. Why would they do that? Why was our CIA so obsessed that they were looking into the best way to fake film and then classified it into like 2011 or something?
Was it them that came up with the front screen technology, or was that Kubrick? Was that his idea?
I don't know anything about
Front,
that.
Have you looked at the virtual moon thing from NASA? I have it posted on my Twitter.
Mm.
I've got to say, Taylor, that some of the shit you repost on Twitter is rubbish.
What? Give me an example.
Oh, just really, really way out there. Like lizard people type of shit, right?
Well, they're in the Bible. Dead Sea Scrolls.
Okay.
I mean, I've talked to people who've had firsthand testimony, like getting abducted by these
Okay.
demons. So, I'm not positing it as fact. Like, if I did posit something as fact, I'd like post the sources and stuff like I usually do. But this is just like firsthand accounts. So I mean, you can't really like debunk it or like verify it either way. So
Wait, but shouldn't we have lizard people if evolution's real?
yeah,
Like, wouldn't some of the lizards wanted to kind of be like people like?
they say we have a reptilian brain, but that's just like misconstrued. It's just stupid. They say we come from fish.
and wouldn't there
The
be
grandpa's a fish.
also almost humans, like some type of species that way? Like a monkey that's almost human. There should be a lot there, but yeah.
No, they all died, but the monkeys stayed alive, and then the humans stayed alive. That's actually what they say. It's just stupid. You would have like tons of transitional species.
The best explanation in regards to evolution that I've ever heard was definitely satirical through South Park, where Mr.
Like the
Garrett
fish bowl.
yeah, that. Yeah.
But there's
Retired
never
squirrel
been
monkey
one
got
transitional
defiled.
species. Like, there's not even one transitional species. There should be millions.
In the fossil record too. What is
I
that
genuinely don't get
real
that part.
Unreal
I don't.
Engine? That's what I was thinking of. Okay, so NASA had this paper on Unreal Engine footage of the moon. And like they were gonna use it for the Apollo missions and stuff. They posted a paper on it. Unreal Engine is what you use to make video games.
Yeah, video
'Cause, they
games
made like a
and very
replica.
high-end types of CGI.
They
It's
made a
pretty amazing.
replica of the moon where they brought an artist in to like precisely replicate every crater on the moon in this giant like model. And then they put a camera on they built a little track where the camera went around it, getting like really close up shots of the like 3D replica that they brought the artist in with close up pictures of the moon that he held up to it to paint it to perfectly replicate it. What? Why did they build it? Why would NASA build it? The best argument I've heard for a lot of this is that they were they were making plans in case they needed to fake it, and they ended up not needing to. Someone
Here we
actually told
go.
me.
Spacear's virtual moon. Unreal Engine lets NASA create hyper-real virtual environments of the lunar surface. It says that they're doing it to let the astronauts to practice navigation and familiarize themselves with the terrain. And has high fidelity rendering real time lightning effects with features like lumen and terrain management. And it integrates NASA's existing engineering tools, letting you like have detailed analysis of mission parameters. And basically, this integration supports the development of a digital twin for testing designs without the need for costly physical prototypes.
Cool.
Yeah, they put a lot of money into this like AI stuff. It's kind of weird.
They put a ton of money into the world's most sophisticated harnesses as well that you can't see, that they use for like plays and stuff like that, for like acrobatic stunts and plays. So
I would like to hear things that Taylor does not find weird.
the Earth is stationary.
Nice.
You said you wanted to hear things Taylor didn't think was weird.
Yeah. That's pretty good.
I mean, yeah, I don't believe every like conspiracy theory, but you know, in terms of what we say is happening in reality now, I would like to see evidence for it. You should be able to verify it using the scientific method and experimentation, controlled experiments.
Yeah, Ruhif, I don't know if you remember this, but you were on with Shane and them a while back, and they were asking you like what a good way to measure like the Earth, if there would be a way to do that by, you know, occluding the star at a certain time. Do you remember talking to them about that, like before they did
Let's
that
discover that.
experiment?
It would have been
Before they
after.
did this
They brought it up, right?
celestial theodolite, you weren't talking about it before with them, like about how you can.
No, they brought it up. Yeah, I didn't come up with it first like they did.
I thought they had asked
It
you
doesn't matter.
like if that would have
It
been a
doesn't matter.
sufficient, but now you say that it's not correct, or you still want to. I think it was when you wanted to take away refraction, and they came up with the idea to take away the refraction. But then when they showed
Yeah,
you the
can't do.
distances from, yeah, when they showed you all the distances, you kept wanting to add back on the refraction. I was just wondering why would you, excuse me, why would you do that?
Because we're always looking through an atmosphere. When are we not
But
looking
if
through an
the
atmosphere?
but I think what the contention was is the terrestrial refraction that wouldn't like be able to block the stars or whatever.
Why
Yeah, like that
not?
was.
And that was the one in the contention. They would say, yeah, the stars can be refracted to appear higher or lower. And I think that they, in some of their analyses, they compensated for that and tried to incorporate it and still didn't match up with the globe prediction. But like, okay, but then like
Path.
in Jesse's thing, whenever he was like I think he made the spreadsheet and stuff where you can input the like distances and locations and like try to like predict
Yep.
what the angle would be in the timing.
Yep.
They were in contention with him adding terrestrial refraction, where as
Oh.
like basically like the mountain would be shifting, like
Yes.
because even if the mountain was shifting like visually, like optically, it wouldn't be able to occlude it as if it was actually there. So if the mountain was appearing taller due to refraction, it wouldn't be able to like obstruct, you know, some like a star or light or anything.
This is where everyone. I don't know whether they overthink refraction. Right, all it is the path that the light takes is curved, right? And the mountain is blocking that curved path. Like it's not any more complex than that.
Okay, but the mountain's not like the mountain
Yeah.
itself, if it was refracted, wouldn't occlude it. Can we agree on
Yes,
that?
it would. The path
So
of light is
apparent objects
curved,
can
right?
block light.
Yes. You'll see it
Can
in
you
its
demonstrate
apparent
that
position.
happening at all?
I will show you what's happening. Give me a minute to get this. Where's my
Can you
meme for it?
demonstrate that happening? Like an
Do you accept
apparent
that light
object?
takes
Like
a curved
it's just
path?
an optical illusion that it's there. It's not actually there. So if
Well,
there was like a
it is there.
flashlight behind it, for
It is
example,
there, but the light is taking a curved path.
okay,
You
it doesn't.
accept that
I
light
get
takes a
that.
curved path.
I
Okay.
get that. Okay,
Then the
so
actual object is blocking the curved path.
okay, the actual
Why is
object,
that hard? Yes.
not the apparent object, right?
It's not an apparent object. You see it
The
in an
mountain.
apparent position
Oh
because
my
the
God.
light is coming in at an angle that is different to the geometric angle. It's the
Okay,
Yeah, and
so if the
physical
mountain
mountain.
if the
there's
mountain
two
was being
separate things.
refracted in our position to appear taller, that would not change when the actual mountain occludes like an actual light source. You see what I mean?
You must
Like, and from what
account
I
for
understand,
refraction.
that's why the celestial theodolite comes into play. is it takes away refraction. Like I don't
No, it
understand why
doesn't.
you don't understand. Well,
I understand it. We're looking through an atmosphere. That optical
dude, you seem
path
to be like the
between me and
only
the
one
mountain is
that
curved.
doesn't understand it. It's crazy.
I
Like
Before we
I
move on to
guarantee you
understand
I
that,
understand it.
I want Ruhif to acknowledge though that like just because something appears to be in a position in our perspective because of terrestrial refraction doesn't mean that it's actually there or that it would block
Right.
any light source.
It,
We can use
it
a
blocks
flashlight
light.
or a laser, for example.
It
So if
blocks
we're
light. That mountain, the curved path of light is being blocked by the mountain.
okay,
Physically.
let's give a scenario. There's a laser
I'll draw it.
that's shooting. There's a laser that's being shot like directly over the head of the mountain. Okay, like in reality, right? Now, if because of terrestrial refraction, we see the mountain appear to be taller, it would not all of a suddenly block that laser. So we can appear it to be taller, whereas if that was the actual position, it would block the laser, you know? So but in reality, it would not block the laser in reality. Just because it appears to be higher from our perspective, it would not block like a laser behind it. Do you see what that's shooting over the top of it? Do you see what I mean? Can you acknowledge that?
Can you see my screen?
But I think I laid out, like I spent time and energy just laying out that hypothetical. Can you respond to it?
Yeah, I don't know how else to say it. That the light is taking a curved path, and that curved path through space is being blocked by something physical.
Okay, by
It's not
something
difficult.
physical. So even
Yeah.
if the mountain appeared taller as an optical illusion to the observer, it still wouldn't block the laser that's
Yes, it
actually
would.
shooting over the mountain to the observer, right?
Oh, just let me draw it.
Yes or
Okay,
no?
Ruhif, do you understand? Yeah. I'm sorry. Go ahead.
Delete.
Can you acknowledge that, Ruhiv?
Hang on, I'm just drawing.
Can you just respond? It's a very
I'm
simple
drawing.
question.
No, hang on.
An apparent object does not physically obstruct light.
Yes, it does.
It's just
You just see the physical object in its apparent position, right?
Okay,
how does an
Ruhif.
apparent
Okay, tell me
object
this,
block light?
Ruhif.
There's no
I got
such
a
thing as an
question. So,
apparent object.
That's stupid.
are there two different timings for a globe and a flat Earth? Like, wouldn't you have those two separate? You'd have different readings, right? If like you guys have
The
been going from
globe,
Pikes Peak, the globe
the
has a
globe has a
prediction, and
better prediction.
no, they do
The
not,
globe
dude.
predicts the timing better than the celestial theodolite. Yes, it
Oh
does.
my god, bro! They got all kinds of data on this, all kinds of. You
Yeah.
guys have made them go through all this shit, and like, dude, it's two separate triangles. It's that easy. The globe has a triangle, and the flat Earth has a triangle, and the
Now
flat Earth
Right.
matches every time.
do the
No, it
refracted
doesn't.
mountain.
No, it doesn't.
Draw the refracted mountain where it appears taller, please.
Sure. Do I,
You cannot have an inclusion with
transparency?
refraction,
Make
bro.
it like a lighter gray color.
Yeah, I'm trying to. All right, there you go. All right, so that's where you see the mountain, right? That's its apparent position, but the light is taking a curved path and it gets blocked as soon as the star goes a tiny bit lower. But you see this occlusion happening. You see